keep the introductions to a minimum, since I think everyone has been here most days so far. I'll just repeat. Could everyone please have their mobiles either on silent or turned off, please? We're not expecting any fire drills today, and the fire exits are, the nearest one is the front door. Toilets are outside and to your right. We're making very good progress so far. We're not slipping behind, slightly ahead of schedule. So just wanted initially to start with an idea of timings and witnesses for today, and then perhaps thinking about the early part of next week. Mr. Cullen, do you have any thoughts on how today might go?
Yes, ma'am. First of all, just for information, as everybody is now gathered, can I say that the question of the Town Centre Forum was raised in an exchange yesterday, and steps have been taken to, people knew what it was, but it was finding a document that actually spelled that out. That's been done. I'm not in a position to distribute it this morning, but the idea would be, first of all, we can deal with it during the community engagement session, and secondly, if there's a short document available, we'll simply produce that and give Mr. Dowson and so on copies of it. That's just as soon as it's available.
Thank you.
So that will deal with that issue. So far as timing is concerned, I've been reviewing witnesses and topics and so on and so forth. What is currently proposed, subject of course to your direction, is that we would make available today 4 witnesses, Mr. Swift, Mr. Jolly, Mr. Sharp and Mr. Callender. Now, it's a little bit of an inexact science to know how that will play out, but given the stage that we've reached and the progress we've made, that's what I was proposing to have available today. That would mean there would be 1 remaining witness only on technical matters to be dealt with next week. And in the meantime, while we're sitting here, efforts are being made to recheck availability of witnesses on other topics, with a view to seeing, subject of course to the views of others, whether we can in effect just carry on as soon as we finish technical and move on to the next topic, which is townscape and visual and heritage and so on. So that's what we're seeking to check the availability for. I don't have that information as we speak, but I'm very hopeful that we can make progress in that way.
Would you expect to know by the end of the day, Mr. Cullen, or would it be Monday, sorry, Tuesday, before we know?
If I get information in the course of the day, it was raised yesterday. Obviously, it depends on people, whether they're in their offices or picking up their emails or whatever. The idea is certainly to pursue it today, and if I can get some confirmation on that in the course of today while we're all assembled, I would propose to let everybody know at a suitable break. Likewise, if there's a difficulty with any of that, I'll let parties know. I'm reasonably hopeful it will work out, but I just need to get confirmation for the individual witnesses, failing which, well, if we're reconvening on Tuesday, I would certainly want to circulate something just as soon as we know that it's possible.
That's very much appreciated. Mr. Dowson, do you have any thoughts on that?
Very happy to go along with that, and I would appreciate it if perhaps a sketch timetable could be drawn up, and that would give me the opportunity then perhaps to just check with any witnesses that we have that they would be available on those dates. So subject to our people being able to alter times and things like that, we'd be happy to go along with that. Yeah.
Mr. Connell, would you expect to finish leading evidence on Mr. Swift before the morning break?
Yes. I mean, I have 1, possibly 2 supplementary questions for Mr. Swift, but otherwise I'm intending to confine, asking him to read his summary precognition as required.
Mr Dowson, what are your feelings on timings for cross-examining witnesses today?
I've been a bit cautious about giving times after yesterday. I'm guessing at about 40 to 45 minutes.
Thank you. Does anyone have any other matters that they wish to raise about procedural matters at this point in time? Okay. Mr Connell, if you're ready, could I hand over to you now, please?
Thank you, ma'am. The first witness for this morning is Mr Paul Swift, who's already ensconced in the witness chair. The role that you played, I think, Mr Swift, was of project manager. Is that correct? On and off, like I have just failed to do. And you're then going to be followed by another witness from your organisation, Mr Jolly, who, as I understand it, was the technical leader or some other such title on hydrological matters. Is that fair?
That's correct.
So you cover a range of matters, but if there's some very detailed hydrological matter, it might be best to hold that over for Mr Jolly, subject, of course, to the direction of others.
Okay. My name is Paul Swift. I obtained a Bachelor of Engineering honours degree in Civil Engineering in 1992. I'm a member of the Engineering Council and a Fellow of the Chartered Institution of Water and Environmental Management. I'm an Associate Director at WSP Limited. Scope of evidence. My evidence for this inquiry focuses on the option selection process and level of protection. Evidence. Option and scheme development. Jacobs Report 2007. Jacobs Report titled Whitesands Flood Risk Appraisal Report Jacobs 2007 assessed numerous types of options including direct defences, fixed, demountable and raisable, offline and online storage and combinations of them. The report presented the hydraulic and economic appraisals for these options. All the options were economically viable. Option 3B, which entailed direct defences in Whitesands combined with the use of the floodplain upstream of Dalscombe by creating a breach in the existing upstream embankments, was considered the most cost-effective. The report concluded by recommending that a further detailed assessment be undertaken into the preferred option. It is worth noting that Jacobs concluded in this report that neither the offline nor online storage prevented flooding at Whitesands, and that therefore direct defences at Whitesands would be required in conjunction with any offline or online storage option under consideration.
Can I just ask you, just if I can just intervene for a second, just, I know we're summarising offline and online, just for the benefit of those who are not familiar with those phrases. Can you tell us what they mean?
Yes, certainly. Online storage is the storage of flood water on the line of the river. So what you would do is create a dam within the river channel to store water in the channel itself. Offline storage is where you use the adjacent floodplain, so you'd redirect flood water from the river to adjacent floodplains, store it there and allow it to discharge back afterwards.
Thank you, Mr Swift. Could you continue with your summary recognition?
Michel option assessment. Michel reviewed the Jacobs hydrological and hydraulic river model. The review identified a number of updates which were required to the model before it was used to further assess the options. Although the original commission was to review the preferred option identified in the Jacobs report, the initial modelling produced an unusual result. As a consequence, the work scope was widened to review the following options. Option 1, direct defences in Whitesands but without any breach in the existing upstream embankments. This was option 1B in the Whitesands Flood Risk Appraisal Report, Jacobs 2007. Option 2, direct defences in Whitesands but with a breach in the existing upstream embankments. This was the preferred option identified in the Whitesands Flood Risk Appraisal Report. Option 3, base model with gravel removal downstream of the weir. This option was assessed at the request of the Council to determine the impacts the gravel bar downstream of the weir was having on the flooding in Whitesands. The hydraulic modelling results were as follows. Option 1, there was little change in the water levels from the base model. Option 2, water levels increased from the base case model in the Whitesands area for the 100 and 200 year level of protection. This is because once the water has filled up in the Dalscone storage area, it then spills back into the river system before the flood peak, therefore increasing peak water level in Whitesands. This is referred to elsewhere as the synchronisation effect. Option 3, there was negligible change from the base model. We concluded that the removal of the gravel island did not influence the flooding in Whitesands. In November 2011, we presented the hydrological and hydraulic model results to the Council. The conclusion reached was that option 1 was the preferred option based on hydraulic performance. Following the presentation of our draft results in November 2011, the Council presented their recommendations to a Council Committee meeting in December 2011. Following the Council Committee decision, Mouchel were instructed to assess 2 additional options. These were direct defences in Whitesands for the 1 in 10, option 3, and 25-year level protection, option 4. These additional options were being assessed because the Council concluded the 1 in 200-year level of protection would cause severe visual impact on the townscape. We reported our findings from the 2011 study and the assessment of the additional options to the Council in our technical report, Mouchel, May 2013. Options 1, 3 and 4 were all determined to be economically viable. An economic appraisal was not undertaken for option 2 as it had been discounted by the Council in the December 2011 committee. We were also asked by the Council to consider temporary and demountable flood protection equipment. Using the guidance set out in the R&D publication 130, DEFRA EA 2002, we assessed the options having regard to the following considerations which were specific to Whitesands.
Can I just ask, sorry, the temporary and demountable, is that solely reliant on temporary and demountable as opposed to something permanent with some additional demountables on?
Sorry, Mr. Connell, could you just repeat that?
Sorry, in that section you're referring to being asked to consider temporary and demountable flood protection equipment. In that section, are you dealing with something that's only brought in for a flood?
Yes, that's correct. So it'll be equipment that isn't permanently in place. It'll be stored elsewhere and it'll be brought to site just for the purposes of flood protection.
Thank you very much. If you could continue, please.
Using the guidance set out in the R&D publication 130, we assessed the options having regard to the following considerations which were specific to Whitesands. Flood warning and forecast system and the time available to deploy necessary resources. Standard of protection. The modelling showed that the maximum depths of water in a 1 in 25-year return period were 2.9 metres. As this ruled out most of the temporary protection systems available, we looked at defences which would provide a 1 in 10 level of protection. Area to be protected, the operation and maintenance requirements of each system, structural integrity and robustness to withstand the hydraulic and impact forces, the ability to keep the Whitesands open during a flood event, and the urban drainage issues. The only option which met all the relevant criteria was the demountable panel systems. All others were discounted for various reasons. It should also be noted that, as set out in section 9.6 of the report, at the time of the report was written, the Environment Agency were not encouraging the use of temporary flood defence systems as permanent solutions over considerable lengths and heights due to the associated operational and maintenance costs and the risk associated with its erection in times of flood for considerable lengths and heights. Flood warning and forecast systems continue to improve, and as James McLeod states in his evidence, the Council will typically receive notice. Scheme development from 2012 to 2016. In parallel with the work undertaken by WSP, the Council initiated a process to design and develop a master plan for the Whitesands. From May 2013 to April 2016, Gillespie's refined the flood defence alignment. When they did so, Michelle were requested to represent the new alignments in the hydraulic model and report on the updated river levels. This work resulted in our river modelling, topographic and Gillespie's alignment update technical note, Michelle 2013. The report presented the updated river levels for the 1 in 25, 1 in 100 and 1 in 200 year level of protection as before, but also included the 1 in 75 year level of protection. This was included so the heights of other levels of protection could be assessed so the Council could make a more informed decision on the optimum balance between the level of protection and the landscape and visual impacts. The conclusion of that report was that the incorporation of the Gillespie's defence alignment, water levels for the 1 in 25 and the 1 in 75 year flood extents were effectively similar to the baseline model in the Whitesands, except for localised increase in levels upstream. SEPA in their hearing statement comment on this and stated it was not a materially significant increase.
That's the issue of Nunham that we've been discussing already in the inquiry, is it?
That's correct. In 2014, we undertook an assessment to identify what measures could be implemented to offset the identified increases in upstream water levels. Our report titled Devigiller Bridge, Additional River Measures, Michelle 2014, presented our findings. The conclusion of that report was that option 2, removal of sediment under the Devigiller Bridge, was the most viable option when maintenance and hydraulics are considered. It also has the benefit of restoring the channel to its historic form. Another option assessed in this report was natural flood management, which is the use of the upstream catchment to help contain and slow floodwater. Our assessment concluded natural flood management did not lower water levels sufficiently and was discounted as an option for inclusion in the project. We also consulted with SEPA on this matter, who concurred with our conclusions. A report titled Physical Restoration Options to Address Morphology and Flood Pressures on the River Nith, a pilot study, CBEC Eco-Engineering 2013, issued prior to our report, confirmed the SEPA view, which supported our own. The non-home residents' preferred option, option 6, local flood defences, would require additional land take and therefore was not selected by the Council. Self-rising barrier. In 2014, the self-closing barrier system was reviewed to determine if the product could be included in the scheme design. The Council's decision was to proceed with the town centre defences involving the raised walkway and demountables. The use of the self-rising barriers at Whitesands would involve a much longer linear length of installed barrier than I am aware of anywhere else, and so I can understand and would support the Council's recommendation not to proceed with this option. Further, the Council has demonstrated the self-rising barrier is a more costly option. Level of protection. The final level of protection of a 1 in 75 years is a balance between flood protection and the landscape and visual aspects, and has taken account of public feedback received during consultation events. It should be noted, delivering sustainable flood risk management, Scottish Government does not stipulate that a prescribed set level of protection should. Climate. The scheme
think they fixed it, but if it happens again, we might need to. But it would mean that if we pick up a little, particularly their backs to the audience. Would you like to continue, Mr. Swift? Thank you.
I was just going to, perhaps, given the break, can I just ask Mr. Swift? I think you've just told us about the climate change design. Is that the matter that Mr. MacLeod discussed in his evidence yesterday? He was talking about the concrete and so on.
Yes, that's the same topic.
Thank you. If you could perhaps just continue.
Okay, I'll continue from geotechnical. The foundation design also protects against flood water seeping under or through the flood defences. It does this by providing an impermeable barrier in the defences to a calculated depth below ground level. Flood defence products. The scheme uses a variety of products to provide flood protection. The products range from floodgates, demountable barriers, glass panels and property flood resilience. All these products are standard industry products that are used widely across the UK and international flood industry in other flood alleviation schemes. Examples where they are locally used successfully are the Water of Leith Flood Alleviation Scheme, Keswick Flood Alleviation Scheme and Carlisle Flood Alleviation Scheme. Demountable barriers up to heights of 3.2 metres have been installed in a number of flood schemes in recent years.
Sorry, can I just ask there, just so we don't get confused, the demountable barriers that are proposed for the scheme that this inquiry is considering, are they different from the ones we discussed earlier?
No, they're the same.
These ones are to be installed on top of the glass panels, is that correct?
Yes, that's right, yes. Dredging. Dredging has been assessed and it was demonstrated it did not significantly lower water levels in Whitesands. To have any substantial benefit as a standalone option, it would be necessary to remove a significant depth of riverbed material to achieve the required river level reductions. Dredging will also have significant impacts on bridge and river walls, structural stability, river ecology and environment, and the Council's ongoing maintenance commitments. Floods and dredging, a reality check, CIREM 2014, supports the view that dredging is not a standalone option and added, dredging cannot hope to prevent flooding caused when heavy rainfall results in flows that vastly exceed the capacity of the river channel. Conclusions. The option selection process has evolved over a number of years. The process has assessed the full range of options, has been iterative and has taken consideration of a number of factors such as economic, hydraulic, environmental, stakeholder and public consultation feedback and landscape and visual. All these factors have contributed to the selection of the preferred option. In my opinion, the option selection process has been robust and has assessed a full range of options against relevant and appropriate criteria. The scheme before the Ministers has, in my opinion, a number of key strengths, including protection to Whitesands area for a 1 in 75-year level of protection, alleviation of flooding to the Whitesands area from culverted watercourses, highway drainage and a sewer network, and future-proofing to possibly provide protection against the potential impacts of climate change.
Thank you, Mr. Swift. I just have a couple of points I wanted to ask you to follow up on that reading of your summary. One is really just almost for identification. The issue that you referred to as synchronization briefly in your comments. Am I right in understanding that discussion of that has been found in another document subsequently, a SEPA document?
Yes, that's correct.
For reference, I would find that in the SEPA supporting document number 26 at page 107. It's simply a reference. It's used as a case study there. The other question I wanted to ask you was one that cropped up, I think yesterday, which was an issue about seepage into particular house property. And I think I'm right in saying Mr. MacLeod was asked about it and shoveled the ball rapidly in your direction. Are you able to explain about that issue?
Yes, I can do. The document that was referred to is our seepage report, and in one of the concluding chapters, I think it's about titled Further Considerations, it refers to an issue that might need consideration in the future. There's a couple of properties nearby the flood defences. I think it's the Grade A listed building, and there's 2 outbuildings located nearby. The report comments that these 2 buildings, because they're the most adjacent buildings, consideration would be needed to see whether a change in groundwater regime locally may impact on the basements. The report doesn't say it does or it doesn't, but it just makes a note that something would need to be done at a future stage. Actually, the answer to that question is actually in the report as well. I think it's section 522. So what it suggests is that it suggests if it's found that there is some basements in some of those nearby properties, that some groundwater drainage measures behind the defences could be installed just to counteract that. That would negate the need, or that would prevent any water seepage damage to any basements that were there. So the report really just identifies that this is an issue that just needs to be checked out. It identifies the possible solution, which would just be some back of wall groundwater drainage.
Thank you, Mr. Swift. I have nothing further on that point. Thank you.
Mr. Dyson, can I hand over to yourself, please?
Thank you, Mr. Swift, for that. Could we just stay on that subject for a minute and just deal? We might as well deal with that since that's been raised. I did have a little look at that particular report, and I wasn't aware of the solution, the 522 paragraph that you've just told us about. But if I could just maybe ask a few questions in relation to it. I'm not trained in these things, but I'm trying to understand them. The thing that I picked up and I wanted you to clarify was when you build the foundations, it prevents the water coming in from the flood, but it could potentially also stop groundwater getting to the river. Could you comment a bit more on that? Have I understood that correctly?
Yes, it could potentially do that, yes.
Right. The impact of that. The report obviously refers to the fact that flooding water only really happens when the rivers at flood, but groundwater coming down is really coming down all year round. And it suggests that therefore there might be a bigger problem really from groundwater being held from getting to the river than actually the flooding. Would that be reasonable?
What would happen in the design would be that we'd ensure that any groundwater on the dry side would be able to make its way into the river, and that would be through a series of conduits through the defences to allow water to pass through groundwater. We'll have a flat valve on the wet side of the defences to stop ingress of seepage going the other way.
Various points talks about uncertainties in ground conditions and things like that, and the need for further maybe investigations to be carried out. Is that correct?
Yes, I must just add I'm not a geotechnical engineer, but I can answer some of these questions. Yes, it is. I mean, as a scheme develops, we undertake ground investigations as we progress through the scheme. To date, we've had 2 ground investigations. So those ground investigations to date acquire some preliminary data to enable designs to be undertaken. As we proceed through to, so we've had 2 of those already. As we proceed through to detailed design, we'd inevitably get some more, and there'll be more detailed ground investigations. But the level of ground investigation we have at the moment is sufficient for the level of detail that we have at the time.
When you say ground investigations, do you mean trial pits, or yeah? I picked up somewhere that there were some 7 trial pits, I think, along the length in one of the reports. So you've done a couple in maybe in that area. Is that the case?
Yes, that's right. We've done trial pits, we've done boreholes, we've done testing of the materials as well.
I've seen the results from the boreholes, but I may have missed this, but I didn't see any reports on the trial pits. Were they published anywhere?
They'd be, what we usually do, we usually get information from the ground investigation contractor, so they submit a site investigation report, and that details all the information. All that, the report that you see there in the seepage investigation, or the seepage design report, is the assimilation of all that ground investigation data. What they do is create, from that ground investigation data, they create a ground model, and from that ground model they can use that to assess the seepage and do those seepage calculations that inform the outcomes of that report.
And could you tell us very briefly just what the actual ground material is in that location? And is there a thing called a CBR that comes from a trial pit investigation? Is there a particular level of that? Am I using the right terminology?
Yeah, yes, CBR is the Californian bearing ratio. It's been a while since I've used that terminology. So I guess that's just one of a number of parameters that we use to assess the quality of the ground. There's other factors that we use as well. There's other tests that we use as well. So there's a number of tests that we use. Once we acquire the ground investigation data, we get the data, we take it up, we sample it, we sample the soil, and we derive various parameters. So that is just one of those things that we test for.
It's just a thing of public interest that people are interested to know what is down there on the Whitesands, given its historic position as a beach, you know, and sand. And that was one of the things about the level of foundation that would be required at that location. I've read elsewhere that would have to be a minimum of about 1.4 metres, but that's a minimum, I think. Am I correct in that?
If that's what the report says, that's what the report says.
Presumably, the further you go down with foundations, the more likely you are to create seepage barriers in both directions. Is that a reasonable conclusion?
It's a reasonable conclusion. What I would say in our seepage report, at this stage, because at any stage of a project, whilst you've gathered data, but there's more data to gather in later stages of a project, you're always there on the conservative side. So whilst this says a minimum, I'd say that was a conservative estimate, and the reason we do conservative estimates is just because what we have is a robust cost estimate, and so we know we have enough contingency in the cost estimate or it's a worst case scenario, so the defences are probably lower, or don't need to be any lower than they are at the moment.
I'm sure the Reverend Crosby will be quite reassured about your comments. Just one last thing on that. There was one comment you made. You said alternatively it may be the recommendation that any such structure be waterproof during the works. Could you explain what you meant by that, or what is meant?
Okay. Could you tell me the reference to that? I'll just have a quick look.
It's page 21 on the seepage report, second paragraph.
Okay, yeah. I guess what that's saying, whilst I said there's an answer on 5.2.2, which talks about some groundwater measures. An alternative solution here that 6.2.2.1 suggests is that you could waterproof any basements.
So do you do that internally in the basements, or is that what that involves?
Yes, that would be internal. Yes, it would be a tanking tank. Yeah, it would be waterproof in basements.
If we go back to your recognition, perhaps. Okay, yeah. In paragraph 3.2, you say there are three main factors influencing choice of any option. Technical viability, it says sustainability, environmental acceptability, and economic justification. Do you think that the rising, you heard about the rising wall yesterday, I think. Do you think that the rising wall solution would meet those tests as well?
Yes, I mean, I've listened fairly intently to the rise and barrier discussions over the last number of days. As you can see from my recognition, I've got my views on it as well. In terms of starting with the first one, technical viability, I guess there are technical challenges with it. First of all, I'd say it's a relatively new technology, first of all. It's untested over the length that is required in Whitesands. So for me, as a consultant working for a client, it would be difficult for me to recommend that type of solution, a new technology over a distance that is untested, to a client. So for that reason, I'd say, whilst the product is a reasonable product, it does its job. It does its job principally in short durations, short lengths, so typically less than 10 metres. I don't feel it's a suitable solution for a 1.1 kilometre length at the moment, for those reasons. In terms of environmental acceptability, I'd probably, if there's an environmental person coming up, a witness, I'd probably ask you to maybe speak to them about that. In terms of economic justification, I guess the demonstration of that is the council has done a cost estimate and it proves to be more expensive. I'm unsure about the comments about the self-rise and barrier being relatively maintenance-free. I can't imagine it would be. It feels to me that there's a lot of maintenance. I think James McLeod touched on it yesterday. It feels to me there need to be a lot of maintenance that would need to be undertaken to maintain that. So in terms of economic justification, the construction costs on the work we've done demonstrate that the cost of self-rise and barrier is more expensive than the currently prepared option.
Just on the costing then, would you not accept that it's not just about selecting the cheapest option, that sometimes a more expensive option may be more expensive because it's a better quality and perhaps actually a better solution, and it might be worth spending a bit more money to get a better solution?
I can accept that point, but I think I'll refer you back to my previous comment about its technical viability. The product, in my view, is a new technology, and it's untested over the length that we're considering at the moment.
Just on that point then, we're not considering, and certainly we've never considered, and I don't know where 1,100 metres of rising wall came from. Certainly any amendment we would consider would be restricted to about 450 metres. We heard yesterday that that's broken down into lengths of 10 to 15 metres. So if if you were advising a client on dealing with a 10 to 15 metre length, would you be more likely to agree to that?
I'd say for the self-rising barrier, its principal use, as far as I can see, from the documentation I've read, is for typically short lengths. So its principal uses are for openings to buildings or car parks or premises or closing short gaps. So for those instances, I'd say it is a suitable product to use.
So a 10 metre type thing would be, 10 to 15 metres would be a reasonable use for it.
And what I'd say is it's used in those circumstances at the moment, and so for those types of uses, it is applicable. What I'd say is for the situation we have in Whitesands, it's a long linear length that's required, much greater than 10 metres. And therefore, for me, it feels as if it's untested over that particular length. So for 10 metres, closing gaps to premises or buildings or short durations is a suitable option to consider.
So you agree that a 10 metre is suitable?
Well, just based on its current performance, it is. But what I'd say is that the requirement here in Whitesands is for a much longer linear length.
But it's broken down into, you can break it down into 10 metre lengths, and you've just agreed that it's quite suitable for a 10 metre length.
It's I guess what you're trying to say is a 10 metre length. It's not just one 10 metre length; it's a continuous stretch of 10 metre lengths. That's what you're suggesting. There's the length that we require, the total length that we require, is much longer than just a 10 metre short length.
It's a bit like maybe glass panels, which are only 2 metres long. I mean, you break all of these components down into, they work fine in smaller lengths. When you multiply them, you could have 100 glass panels and you'd still be quite happy, because each one...
Mr. Dowson, I think we've pretty much explored that point. Could we move on, please?
And in terms of the economic, social and environmental benefits, I'd say there's the economic benefits are clear. There's a reduction of flood damages. For the social and environmental, I'd say there's other witnesses who can better answer those questions.
Apologies. If we move to paragraph 311, which refers to the Jacobs report, I mean, I assume you agree that well, it's written here that Jacobs did come forward with this idea of a twin approach to flooding on the Whitesands, which did involve the upstream use combined with the barrier. Would you like to comment on that Jacobs report? Or do you agree with that conclusion?
That report was a Jacobs report. I'm not here to present evidence on that or answer questions on its sufficiency. What I would say is that the report is comprehensive in my view. It assesses all the viable options. As part of our brief, we review that report to familiarise ourselves with it, and it was a reasonable report to enable the council to make a good informed decision on the selection of the preferred option.
In paragraph 316, you refer to the preferred option identified in the Jacobs report, but you say the initial modelling produced an unusual result. I didn't quite understand what that meant, what that unusual result was.
Okay, well, you probably heard this over the last number of days. I think James McLeod, a previous witness, talked about it. This is what we call the synchronisation effect. So what happens when we simulate a breach in those upstream informal embankments? For those higher return periods, well, first of all, the water stores on the floodplain. As the water level rises in the floodplain and also in the river, the water in the floodplain spills back over into the river at some point in the flood cycle, in the flood event. What that then does is increase the water level in the river, and actually increases the water level in Dumfries in Whitesands then. That is known as what we call synchronisation.
Thank you. And that brings me to paragraph 317 then, option 2, where you actually mention synchronisation. You say there that the water levels increased from in the Whitesands area for the 100 and 200 year level of protection. My understanding is that, which is limited, is that synchronisation does only happen in these very high flood levels of around 1 in 100 or 200. Is that correct?
Yes, it occurs in those higher events. But what I would say is, well, yes, no, that's fine.
In terms of lower events, for instance, we heard Storm Frank was a 1 in 30. You would not then be likely to get synchronisation on a 1 in 30.
Our model results at the time show that for those lower return periods, the 1 in 10 and the 25, the water level does reduce. I think we had Alistair Moyer here yesterday who was talking about that, and James McLeod, another witness yesterday, talked about that as well. So I think James confirmed that. We're not disputing that happens. We agree. Our modelling confirms that is the case. So in these lower return periods, water levels do reduce, but it's only by a couple of 100 millimetres.
The Jacobs and Baptiste suggested it would be more than that. I think they suggested a figure about 700. Are you aware of that?
No, I'm not.
Given what we heard yesterday about the breach of the embankment, and I think even Mr McLeod accepted that the water, you do get a lower level, whether it's 200 or 700, it does have an impact on the level of defence that you require on the Whitesands. What I'm suggesting here is that if work was done upstream, in terms of the lower flood levels, it would reduce the height of floodwaters on the Whitesands.
I think we just agreed on that, didn't we? Yes, we did say it would lower water levels by 200 millimetres.
We didn't agree on the 200, okay. In 318, you mentioned that option 1 that's without doing works upstream. That you took that decision based on hydraulic performance, but that would have been based on the 1 in 100, 1 in 200 models.
That was from the model that was identified as the preferred option hydraulically. Once we factored in once we've accepted that for the lower return periods, it does lower water levels by of the order of 200 millimetres. To actually have a breach in that upstream embankment, to create a breach in that upstream embankment would entail considerable amounts of work to formalise those upstream embankments. I think James McLeod again talked about it yesterday. So a combination of hydraulic performance and also the need to formalise those upstream embankments, which had come at a considerable cost and also a considerable maintenance cost, as well as those landowner compensation. It was that factor, the hydraulic and also the additional cost, which in the end determined that option 2 was the least favoured option.
That clarifies that it wasn't just hydraulic performance then, it was costs and landowners and other issues as well.
Yes, I think the council's committee report details that.
Paragraph 320 you mentioned, and it was mentioned in 1 or 2 places, that there was some examination of a 1 in 10 option, but that then seemed to have disappeared from your consideration. Could you comment on that as to why the 1 in 10 option was dismissed?
I think what I'd say there, I think that's whilst we presented the results to the council, that then entered into a charrette process. So I think that's another witness will probably best ably answer that question.
Paragraph 323 I was a little bit confused about. You mentioned the depth of water in a bullet point there. A 1 in 25 return period was 2.9 metres. I mean, that sounded quite high for a 1 in 25, because I think your scheme at the moment has the 1 in 25 at 2.5 metres. Could you comment on the difference?
I'd probably say one of our other witnesses could probably best comment on that. That's a witness on hydraulics.
If I could come back to paragraph 330 then, this is where the 1 in 25 and 1 in 75 are mentioned, and SEPA confirmed that that doesn't make materially significant increase. Was that solely in relation to Nunham, or was that a general comment that the difference between a 1 in 25 and 1 in 75 isn't materially significant? The charrette concluded that 1 in 25 which should be pursued, but sometime after the charrette, the council proposal was increased to 1 in 75. And I think one of the reasoning behind that was that it was not considered to be materially significant, the difference. I'm just trying to get at why did we move from 1 in 25 to 1 in 75? When did that happen? How was that decision taken?
So this is paragraph 330. I think you're misinterpreting the paragraph, yes. No, I wasn't involved in the charrette. I was just looking through my precognition because I think I say that in 5.6.
.334, if we just go back to you use the word did not lower water level sufficiently. That's the 200 millimetres, is it? You didn't think that was sufficient?
I think, well, if you're referring to my comment before where I mentioned 200 millimetres, this is a different topic. This is natural flood management now.
Right. Sorry, I have misinterpreted that then. Mm-hmm. Okay, thank you. Yep. Any further comment on 335 just with regard to the Nunham residents? And they had that option 6. I mean, I suggested that perhaps the Nunham residents are a higher priority than the Whitesands. Have you any thoughts on that?
I'd say that's not something I can comment on.
Paragraph 3.39, level of protection. This is where final level of protection of 1 in 75. And it said here that was taking account of public feedback. Okay. It's the issue of insurance. Do you have any knowledge of the fact that is better for insurance purposes?
I do know historically the 1 in 75-year level of protection has been a benchmark whereby insurance companies are more likely to provide insurance.
In 340, and we're coming to climate change, the idea of, I suppose, future-proofing or whatever to increase the flood defence height. How would you increase that height in the future?
I mean, I'd refer you back to James McLeod's evidence yesterday. I think he adequately covered that.
I don't think the public would allow me not to mention dredging. Under paragraph 343, if I could just comment on that. I mean, on behalf of the public, why don't you just take out those islands in the middle of the river?
I can hear a few chuckles behind there. Sorry. I think the reason perhaps there is a few chuckles is because that's been a comment whilst I've been involved in the scheme that removing the gravel islands would have a significant benefit. We've done some, so this is not about, so the question, whilst you've asked it under 3.43, which is dredging, the question you're asking about gravel removal. We've modelled gravel removal, so that was back in my precognition under item 317. So in there I say option 3, there was negligible change from the base model. I think by removing the gravel islands, you lower water levels by about 5 millimetres.
Reasonable answer for the public. You're quite, because I get this all the time, I'm just raising this, that people ask this question about dredging. You're quite convinced that dredging will not make a significant difference.
Well, the question you just asked was gravel removal. I mean, we modelled dredging as well, and again, its benefits wasn't really significant. To lower water levels by dredging by a number of metres would require a considerable depth of dredging to be undertaken, and I think in my premonition I talk about what impacts that will have on various aspects.
Okay. Paragraph 4.2 is about the option selection process, and you say that that has been robust and has assessed a full range of options. I mean, from our side, we are unhappy about that option appraisal method. Can you just tell us why you're satisfied that that was done fully and correctly and fairly?
I'd say the option selection process started back with Jacobs, and they assessed a whole suite of options as you would do at that stage. It was combinations of options, of upstream storage options, online, offline, defences in the town. It was a comprehensive assessment, and they produced a comprehensive report, and they'd done an economic appraisal on each of them, and from there that set the direction of the preferred option. So in that case, and since then, we've looked at that preferred option that came out of the Jacobs report. We've assessed that. We've looked at other options once we identified that perhaps wasn't as, once we looked at it in more detail, it wasn't didn't provide us the benefits or the hydraulic benefits that we wanted, and when we had to try and make it work, there would have been additional cost to that. So my view, it's that we've done a robust assessment of all the options, all the available options that you would normally assess as part of an option appraisal for a study like this.
And just the final, when you talk about the various objections that have come in from the public, and the very final one, paragraph 5.5, you talk about, or the public talked about that the design team had only pursued one design option. You then say that it is normal practice for a preferred option to be pursued. Do you not agree that by pursuing one option from really 2012 onwards, that option has had the benefit of 5 or 6 years of very intensive appraisal, whereas other options coming in at various times have not had the same degree of investigation or assessment or presentation to the public, and therefore, to some extent, we've not been able to compare the options in a fair and equal way?
No, I think I'd disagree with you. I'd say the option appraisal process that has been followed, as we followed it as we should do. I'll refer you back to my previous comments about Jacobs, which I've made just previously, how they've assessed it, and how then we picked up that option and further refined it to identify what is the preferred option. Once you do identify a preferred option, it is normal practice just to develop that option. What I would say is, in fairness to the council, they have assessed other options as they came along, so they haven't not assessed them. Natural flood management came along and became more a viable option. So at the time, once we thought it might be more of a viable option, we assessed it. Once the self-rising barrier manifested itself, and you must remember that is a new technology, it's only come to market relatively recent, the council did assess that option then. So I'd say, in answer to your question, I disagree with you, and I'd say the option appraisal process has been a robust process, and it's normal practice to identify an option and develop that from then onwards.
Well, I'll leave it at that point, just having to disagree with you.
Thank you, Mr. Dyson. Mr. Swift, you've answered most of my points already. At half you, I think I only have one remaining. It's really just a point of clarification. You noted that dredging wouldn't significantly lower water levels at Whitesands. I just wanted to be clear if the effects of dredging on the water levels would vary depending on different scales of flood event.
I'd probably ask you to, that might be one for Tim Jolly, I'd say. Just thinking about hydraulics and hydrology, he could probably best ably answer that.
That's fine, thank you. Mr. Connell, do you have anything further?
I have nothing further for this witness, thank you.
Okay, I think that might be an appropriate point to take a short break. If everyone's happy, we'll reconvene at 5 past. Could we restart, please? I think, hopefully, I would like to manage to complete this witness before we break for lunch. Mr. Connell, do you think that would be feasible?
Well, certainly on my side, ma'am, I only have, I think, one supplementary question where I'd like to ask the witness to explain a little bit more, so I don't anticipate being very long with this witness.
Mr. Dyson, what's your feelings?
No, I would think about 20 minutes.
Thanks very much. Can I hand over to yourself now, Mr. Connell?
Thank you. Now, Mr. Jolly, you're the man that repeated people have been selecting to pass the ball to, because you're the person given the label of hydrologist. But for for this purpose, for this project, you were the person who led, if you like, in terms of the hydrological modelling and so on. Is that correct?
Is it? Yeah. Yeah, that's correct. Yeah.
Obviously, there's quite a lot about modelling in your full precognition, but we'll just ask you to deal with your summary precognition at the moment, if we could. I think we can take as read your name and your qualifications, and indeed 2.1, which simply says what you're here to talk about. So could we go straight to section 3, please?
Okay. I just thought I would start with a definition of a model. In general terms, a hydraulic model is a computer program designed to solve the equations that describe how water flows through a river system. They are generally used to calculate flow velocity and depth for a defined river geometry and a downstream boundary. Models are calibrated for each river system they are applied to, with the parameters most commonly used for calibration being those that represent frictional resistance of the channel and floodplain to flow. Manning's end value is often used for that term. Any energy loss and characteristics of bridges and other structures such as weirs. Turning to the NIF model, the model that I'll describe in my statement has its upstream boundary at Thornhill and extends 40 kilometres downstream to the Solway Estuary at Glen Capel. The model comprises of river channel cross-sections, floodplain topography, bridges, inflows, and a tidal downstream boundary. These elements are required to define the physical characteristics of a river system and flood event being modelled. Purpose of the model. The overall purpose of the model was to inform the defence levels for the scheme and to assess the potential hydraulic impact of the scheme on the Whitesands and surrounding areas. Baseline model. The baseline model is a model of the existing or undefended state of a river system. The original hydraulic model was developed by Jacobs, as detailed in their Jacobs 2007 report. The Jacobs model extends 40 kilometres from Thornhill to Glen Capel. The model was what is termed a one-dimensional 1D hydraulic model and used the commercial software ISIS. The 40 kilometres was represented as 115 river cross-sections and all major hydraulic structures in the form of bridges and weirs from downstream of the A75 trunk road northern viaduct at Delscone to St Michael's Bridge in Dumfries were included. All large floodplain areas between Thornhill and Delscone were represented in the model as 1D storage areas, as were smaller floodplain storage areas. The model was calibrated for the mainly in-bank event of the 6th of March 2007, when the Whitesands area was inundated to a shallow depth, and the outer bank flood event of December 1982. Some of that topographic data in the model had not been updated since 1983, and the Council wanted future modelling to use recent developments in two-dimensional or 2D software. 2D models more accurately represent the model of watercourse of the watercourse. 2D models more accurately represent the movement of water across a floodplain area by accounting for variations in topography and features such as embankments and walls. A review of the Jacobs model was therefore included in our terms of reference when we were appointed by the Council in March 2010. The outcome of the review is set out in our document, the Hydrological Review Report, dated April 2010. Between April 2010 and August 2011, the hydrology and modelling recommendations were implemented and are detailed in section 3.1 of that report. The model was calibrated using a flood event of November 2009 and March 2007. That's in section 3.3 of the 2012 hydraulic modelling report. These events were selected being the most recent events for which flood water levels data sets were available at SEPA's Whitesands and Whitesands stations, and also tidal stage data was available. The model was updated to incorporate topographic survey data received from the Council in August 2013 from the Whitesands floodplain area, as detailed in report reference TMA. The maximum water levels recorded at 7.92 metres above ordnance datum on the 20th of November 2009 at Whitesands, which is equivalent to about just over 600 metres cubed per second at SEPA's Friars Cast gauging station, was exceeded on the 30th of December 2015 during Storm Frank, when the flood level peaked at 8.25 metres above ordnance datum, or 752 metres cubed per second at Friars Cast. And given the significance of this event, the model calibration was reviewed. The results, which are given in our report, Model Recalibration, dated 2016, TM9, show that the recalibration resulted in a reduction in the design levels. Storm Frank was of value not just because it allowed us to review the model calibration, but also because it has an estimated return period of between 25 and 30 years according to SEPA, and I refer you to Hydraulic Modelling Report 2017, Appendix E for that reference.
Is that the point that you may have had some discussion of this? Was it a 30-year event or not in the course of yesterday? Is that where that figure comes from?
Yeah, we made an estimate of the return period. We issued our review to SEPA. They came back, and that reference is in that annex in their response to when we issued the modelling to SEPA, they responded with that response. It was, in their view, it's between a 25 and 30-year return period. Which implies it's of the same order as the design flow for the permanent defences. The results from the recalibrated model gave reduced defence levels, therefore it was important to validate the calibration with additional information, and the Council and SEPA confirmed that the level datums for the SEPA gauges at Whitesands and Whitesands were correct. Second, we checked that the change in calibration did not exceed the statistical uncertainty in SEPA flow estimates at Friars Cast. We also used timestamp photographs and records of the 2015 flood provided by the Council to confirm that the maximum water levels from the revised calibration fitted the event well. So moving now on to the design modelling. We call the calibrated model the baseline model as it represents the current undefended state. We use the baseline model to produce the flood maps and long profiles for a range of return periods. The model was first applied to the options included in our terms of reference, and these are options 1 and 2, which are equivalent to options 1B and 3B as defined in the Jacobs report. So option 1 is to provide protection to Whitesands, Whitesands, Milligreen and Dot Park as defined in the Jacobs 2007 report, which the previous witnesses referred to. Option 2 was referred to as option 3B in that 2007 report, which is with the breach to the embankment upstream of Dumfries. There's also a third option was modelled to assess the impact on flood levels of the removal of gravel from the bed of the River Nith just downstream of the weir to a depth of 0.5 metres, and I'll refer you to figure 4.1 of the 2012 hydraulic modelling report, or TM5, for details of the extent of that option. The 200-year flood levels calculated by the model for each of the three options were compared with the baseline model results at 10 cross-sections between points 190 metres upstream of the Cycle Bridge and 770 metres downstream of St Michael's Bridge. And I refer you to the 2012 hydraulic modelling report, section 4.3 for locations of those points. Removal of a gravel berm downstream of Weir only reduced water levels in Whitesands by up to 5 millimetres due to the large peak flows that are coming down during that event, and also the influence of downstream levels during that event. It was observed in option 2 that the artificial breaching of the embankment upstream of Dumfries could potentially increase the water level at Whitesands and other areas in Dumfries, and previous witnesses have commented on that. Gillespie sent us their first draft alignment for the scheme in August 2013. Drawings and the information provided were used to represent as accurately as possible the proposed flood defence scheme in the hydraulic model by modifying the geometry of the cross-sections, including walls, and modifying hydraulic parameters, such as reflecting changes in surface characteristics. And I refer to section 3 of the technical report, May 2013, for a summary of results. For the summary of the results. In summary, the peak 25-year and 75-year water levels were predicted to increase at Riverside Court, Goldie Crescent, Nunholme Place and the Laundry on the right bank, just downstream of the Cycle Bridge, as a result of that alignment. Figures 3.2 and 3.5 show a detailed comparison of modelled water levels with and without the proposed defences. And these show an increase of 40 to 50 millimetres at Riverside Court, 30 to 40 millimetres at Goldie Crescent, 30 millimetres at Nunholme Place, and 40 millimetres at Laundry adjacent to Cycle Bridge. Levels increased at 2 locations downstream of the scheme, downstream of St Michael's Bridge by 10 millimetres, and did not impact on properties. As a result, the Council directs us to carry out further modelling to identify potential options to address the impacts of the scheme, and this work is reported in the document, the Devagila Bridge Additional River Measures, which the previous witness has reported on, TM11. We first carried out field visits to the area potentially impacted, and to discuss options with the Council. Table 3 in that report, Devagila Bridge Additional River Measures, gives details of the options that were assessed to mitigate for the impact of the scheme on flood levels, and includes very local solutions, e.g. local flood defences or flood resilience measures, through to natural flood management. The report describes how each option was assessed in the model and gives the results as changes in the maximum 75-year flood level of Pacific model cross-sections located between a point 70 metres upstream of the A75 and 920 metres downstream of St Michael's Bridge. During flood conditions, Devagila Bridge has a significant effect on upstream water levels, and therefore the removal of sediment and vegetation at the bridge, which is option 2, is an effective way to address increases in upstream water levels.
I think you're now going to turn to freeboard, so I'll let you go through that, and I may have a supplementary question at the end about it.
Yeah, okay. Okay, turning now to freeboard allowance. Flood defence levels include a freeboard allowance, which acts as a factor of safety to allow for uncertainties in the hydrology and hydraulics. Processes not accounted for, such as surface waves and changes with time, and changes with time, such as embankment settlement. The freeboard was calculated using the Environment Agency Fluvial Freeboard Guidance Note, R&D Technical Note W187, which was current at the time. Since completion of the modelling, the Environment Agency has published revised guidance, which is called Accounting for Residual Uncertainty, and was published in 2017 and was lodged as TM20. That guidance provides a more rigorous overall approach to assessing what factors to include in the factor of safety, but in my judgment would not impact on the hydrology and hydraulic modelling aspects of the freeboard calculation. I'm going to turn now to SEPA and liaison with SEPA. Throughout the project we've liaised with SEPA on hydrology and modelling, and I think you've heard from SEPA on Tuesday in that respect. We first issued the hydrology and hydraulic modelling to SEPA in November 2010 for review. SEPA confirmed that they were satisfied with the design flows and agreed that based on the initial information on model calibration, the river hydraulic modelling looked robust and accurate. The model recalibration report and the recalibrated model was issued to them for their review in September 2016. Turning now to upstream and downstream impacts of the scheme. A technical note was issued in July 2017 giving model results specifically for the Nunholm area, and that's was titled Nunholm Model Results Technical Note, July 2017, TM13. The model used for this assessment was the recalibrated model SEPA is satisfied with. I'd say the only difference between this set of simulations and those presented in the hydraulic modelling report of January 2017 was that we give the model results for cross-sections specifically in the Nunholm area for a wider range of return periods, 5, 25, 75 and 200-year return periods. The proposed scheme results in water level reductions in the Nunholm area compared to the current situation with all return periods tested. The model has identified no increase in maximum water level downstream of Whitesands. Turning now to some comments on some of the specific objections raised to the scheme. Firstly, climate change. A general comment. The calibration of the model gives us confidence that it represents current conditions. Climate change may change the return period we assign to a specific flow in the future, but it doesn't impact on the hydraulics of the model per se. Turning now to some general comments on dredging. The impact of removal of a gravel berm downstream of the weir was negligible. A second assessment reported in our hydraulic modelling report 2017 section 6.5 was carried out whereby channel bed levels were lowered by 100 millimetres between the Cycle Bridge and St Michael's Bridge. The results showed that water levels fall by between 2 millimetres and 61 millimetres, which is not sufficient to contain the design flows generally. Turning now to tidal influences. While levels at Whitesands are influenced by the tide, maximum water levels are dominated by flows in the NIF. Model runs are carried out to assess the sensitivity of the model water levels to the assumed tidal downstream boundary. The results indicated an increase in the tidal level by 1.4 metres at Glen Capel. The 25-year water level would only increase by between 30 millimetres and 80 millimetres in Whitesands, which is well within the freeboard allowance. So finally, my conclusions. In conclusion, we have developed a model that complies with best practice, makes best use of the recorded level data from 2009 and 2015 for calibration, and has been improved by SEPA. SEPA is satisfied with the design flows and the model that have been used to identify potential upstream and downstream impacts. Modelling was used to confirm that the removal of sediment at Devagila Bridge was a hydraulically effective solution to addressing upstream impacts.
Thank you, Mr. Jolly. Can I just ask one or two points? Just to take a general one so far, I think you've had a number of criticisms of the whole idea of modelling. It's all just theory, it doesn't relate to fact. Do you check the model results against actual water levels at any point in the process?
Yeah, I mean, the model's calibrated to start with, so modelling in itself is a process of simulating all the data we can get for the NIF. So in terms of it's basically taking on board actual data. So we've taken on board data that's from SEPA at Fry's Cast. We've taken on SEPA data at Fiddler's Ford in terms of flow data, their flow records. We've taken on their data at Greensands and Whitesands. And that's the primary source of data because in terms of secret recommendations and in terms of standards, we have to focus on their data sets primarily. When we then look at calibration, we then look beyond that to validate the extent of the model. So we then, particularly in terms of the 2015 events and the 2007 event and 2009 events, we then look to the Council for photographic evidence to ensure that the extent of our models confirms with the outer limits of flooding and the timing of that flooding, etc. So, yeah, every effort's made to ensure that it complies with data we can get, whether it's quantitative or anecdotal or qualitative to that extent. Yeah. Sorry, I'm not.
Just a couple more. We know now that the proposed height of defence designed to deal with a 1 in 25 year event, i.e. the permanent defences, is 2.5 metres, and then there's the demountables which take it up to the 1 in 75 event. Are these figures that have been checked against the modelling? I think what I was trying to get at, there was some confusion about how the heights had changed in terms of the modelling. We now have a permanent height to deal with 1 in 25 events of 2.5 metres of defence. Can you comment as to how we got to that figure?
I can't comment on how we have got to the design standard specifically, but I can, in terms of how the design standard has evolved. What I can comment on is so I can comment on so as the scheme has evolved, I can comment on how the modelling how we've evolved from modelling from a 1 in 25 year event through to 1 in 75 year event, and how we've looked at freeboard on top of that, and how the defence levels have evolved through that. But in terms of the decision-making process, I can't comment on that.
I understand you're not involved in that. What impact did the recalibration to the Storm Frank figures in 2015 have in general terms?
Recalibration of the model, in general terms, brought the levels down. So when we recalibrated the model, the model water level, the 1 in 25 year level, brought the levels down. In general terms, of the order of half a metre. But that's just general terms I'm talking now. The levels, the results are in the 2017 report. I can direct you to those. And that's why the recalibration report, 2016 report, was produced, and a lot of effort was put into validating those results. I mean, there's a lot of I'm not careful my words, but obviously when those results were produced, but when you recalibrate a model and it gives you that order of difference, you want to take care. So we naturally, there's a number of checks that you go through, and that recalibration report sets out those checks that we've been through to confirm that we've been through those checks. So that brought those defence levels down. We went back to the council with those results, and that's what I've set out in my recognition of some of those checks. In addition to that, there's other aspects to that answer. I would say that when we make allowances for uncertainty in freeboard, for example, hydrological uncertainty is incorporated into freeboard, and so when it came to the looking at that hydrological uncertainty and the allowance we made into freeboard, we ensured that the uncertainty we allowed in freeboard was not smaller than at least captured the variation, at least captured what we were seeing in that the differences that we were seeing between the calibration error we were seeing in our modelling. So that we were not making assumptions in our freeboard that we were not underestimating the uncertainty that we're seeing in our modelling. So we were not under-predicting that uncertainty. The uncertainty is being carried forward into the freeboard. And those are the results that you'll see in our 2016 report.
Just maybe gives me one question to ask on that topic. There's been some discussion of what you, in the sense of the project, has done about making provision for freeboarding. You've set out obviously some information in your recognition, but can you summarise the approach taken to freeboarding in relation to the the heights of these defences?
Yeah. So freeboard, the methodology that I spelt out previously incorporates a number of components. So it's hydrology and hydraulic uncertainty, they call component, in which you make a qualitative assessment of how certain am I in that side of things. And then there's a physical component, so what's the scheme made of? Is that likely to change in time? Is it likely to settle, for example? And then there's things like, for example, is it likely to be overtopped by waves? Have we allowed for waves? Is it on a bend? Have I allowed for surcharge around that bend, etc.? So, other things that are likely to happen which I've not accounted for in my modelling, which I should have accounted for. So that's what freeboard is there to account for. And that's what that methodology I've referred to includes, and we have included those. So when we do our calculation, those are the things that are built into that calc. And there's a calculation there behind it that we've presented to do that. And that's what our calculation includes. So our calculations include that. I think, as Sipa said on Tuesday, there's no standard guidance in Scotland for freeboard. It's down to local authority to take a decision on that. And we, as a consultant, advise the local authority in this particular instance as to what freeboard they should take based on our assessment of this particular scheme. And it's for this particular scheme, we did the calculations based on the modelling, and because and that's what we did. We basically used that methodology. Now, if I was to point you at any UK methodology, I'd probably point you at the EA Fluvial Guidance, Chapter 9. I think again, which is lodged with the inquiry. I think it's Chapter 9 of the Fluvial Guidance, which says that we should probably be using the EA standard guidance, and that's the guidance we've used. So that's probably the only reference point I can give you, is saying, yeah, we've used standard guidance.
And in terms of, does the scheme as currently designed incorporate freeboard allowance? What's the answer to that?
Yeah, it does. Yeah.
Nothing further, sir.
Mr. Dyson, do you have some questions? Yeah.
Oh, sorry. Right. If we could just follow on that one a wee bit, and you mentioned the calibration, and that allowed you to reduce, or in terms of your model, reduce the height. And you mentioned the figure of 500 or half a metre. So prior to that recalibration, or prior to you knowing about that half a metre that you could take off, a 1 in 25 scheme would therefore have had to be 3 metres high. Would that be correct?
Yeah, it didn't allow us to take off 500 millimetres. It's a recalibration, so it is a recalibration. It's not a matter of adding or taking. It's a recalibration. So it's a piece of new information that comes to us as modelers. It's a piece of information we didn't have before, so we recalibrate the model. We now have a piece of information. We recalibrate the model. We have some understanding we didn't have previously. We recalibrate the model, and as we retune that model, the model is now telling us that probably now that the 1 in 25 year is, as I was saying, I can go to report, but just to keep things fairly quickly, I'd say it was of the order of magnitude. In places it was up to half a metre less than what it was previously. So it led us to that report in 2016 which says, let's go back and have a look in detail as to understand where that's coming from.
I'm not sure that I'm fully understanding you, because the recalibrated height is 2.5 metres. So what would have been the height prior to recalibration, or to the calibration?
Do you want me to take you to a table then where...
Well, if you could just answer
I don't know. I can tell you a figure off the top of my head. I'd probably have to take you figure. I'd probably have to go to the figures. So the 2012 report will give you the pre-calibrated figures, and the so the report in 2017 will give you the post-calibration figures. So what we're working with now is obviously the calibrated model. That's our 1 in 25-year, 175-year model.
I'm just trying to keep it simple. That it seemed to me that.
But calibration's not. It's not. To clarify, it's not a reduction. It's a calibration process. So it's not a reduction.
And I'm struggling with this one. I must
Would there
admit.
be some merit in you taking us to one of the points in the report? Would that help?
If you wish to, yeah.
Does the 2017 report give Mr. Dowson an explanation as to how the height of the current flood protection scheme was arrived at?
It does, yes. And do you want me to point you?
Yeah, could you please point to it? That might be helpful. Can you tell us which number that document is?
The 2012 report actually was lodged, I think it was SD12, the actual hydraulic modelling report. Am I right? SD12 was the original, was the one that Paul lodged as. Well, the recalibration note is TM. Let me just get you. So it's TM9, I think it's the recalibration. So TM9. So report TM9 will explain to you. So report TM9 will take you through how the model was recalibrated, so how we get from what the levels are before. So let me see if I can find an appropriate table that will answer your question in terms of what they were before. And
Could it be table 8?
in
TM9?
Well, I would,
Near the back?
If it helps, there's a comment at Section 8 recommendation saying it's recommended that the flood defence levels given in Table 7 are adopted. Does that help? Mr. Jolly, I think.
so what I can, Figure 1 and Figure 2 in that report, I haven't got, I'd have to just, Figure 1 and Figure 2 in the TM9 give you the before and after calibration. So they give you the, at the two. But what they don't give us, what I'd have to, so they give you an indication at Whitesands of the change in level.
Mr. Jolly, am I correct in thinking that the recalibration talks about different predictions of heights of water level rather than looking at differences in heights of the flood defences? It's not just simply saying that half a metre is going to come off the flood defences, is that correct?
Yeah, the recalibration is about water level, so it's about, that's what the model is about initially, and then on top of that, once we've done the hydraulics, we'll then talk about defence levels, and then we'll talk about freeboard on top of that. Yeah.
So it's not just a simple equation, it's not just a point we're going to find in that report that says half a metre is going to come off the height of the flood defences.
No, exactly. Yeah, no. This is exactly. This is a modelling report. So this is about hydraulic modelling. Yeah.
Mr. Dowson, are you happy to move on then?
Yeah, I'm happy to move on. I just wanted to be clear in my own mind that the calibration therefore did not affect the height of the defences. Is that what we're saying? Was before the calibration and after, the level or the height of 2.5 metres was constant. There was no difference.
I don't know if I can answer that right now.
Let's leave it for just now,
Yeah.
I think. But I think it's something we would like an answer to at some point. Thank you.
Sorry, Mr. Cullen, if you're content, we could come back and clarify that point later on today, if you wish.
Thank you.
In relation, there's been a lot, or you mentioned a lot about freeboard, and freeboard is incorporated in the calculation. And you've told us a lot about the calculation, but you haven't actually told us what the figure was. Can you tell us?
Yeah, there's a table in. Again, I think it's in the. I'm getting myself in a little bit confused here, but I'm going to direct you to the design statement. The initial calculations were done in so again, the same report, the initial hydraulic modelling report, so that's TM10. So that's where the first calculations, that's where the initial freeboard calcs were done. So again, in Table 8.2 of that, you will find the calculations. Well, not the calculations, you'll find the values. If you want the actual calculations, then the calculations provided to the, the calculations were provided to the council, etc. I've not got the calculations
Okay, so
with me, but
so
I can tell you how
okay.
the calculations are done if you wish to.
Well, again, I mean, I think it's important to know what the freeboard allowance actually is.
The numbers are in the table. The numbers are in Table 8.2. So if you want to go down the cross sections and you want to look at those, also the freeboard is presented in the I can't remember what it's called now, but not the design statement. The forgot the name of the document. The design statement that accompanies the flood prevention order. Yes, the design justification. Yeah, exactly. That document, you will find the freeboard.
I'm just thinking about where this is leading. Right, well, it's been explained that it's been
So
taken
the
into
freeboard
account,
is-
and that what SEPA's advice has been on the matter.
Yeah.
Have you got a question for Mr. Jolly in terms of was that figure acceptable or not, Mr. Dowson?
Well, yeah, but perhaps afterwards we'll get. We'll follow this up afterwards. But on the first day, I talked to SEPA very briefly about freeboard, and they said or suggested that there was a sort of standard figure of 0.5 to 0.6 of a metre. So, I mean, just a simple question in broad terms: does the freeboard in this scheme meet that?
It does, and it doesn't have to meet it, is the simple answer, because SEPA don't have a standard.
I'd read somewhere elsewhere that perhaps the council had taken the decision to only have a 300 freeboard in the calculation. This is all I was really trying to get to. And I was comparing that with maybe the SEPA recommendation of 500 to 600. It sounded to me that that was therefore about half of what SEPA would recommend.
Is that a question? So I didn't.
Yes, I don't know. I'm asking, is that correct?
No, the answer. I think I answered that earlier in that for this particular scheme, we calculated the freeboard for the scheme, and we made a recommendation to the council for the freeboard for this scheme, and they accepted it. And that's the answer for the scheme.
Climate change, would you advise the council on what kind of height or percentage might be recommended for a climate change if you were designing a climate change factor into this?
No, SEPA make recommendations on climate change in Scotland. So at the time this scheme was being developed, their recommendation was 20%. Their current recommendation is 44% in this part of Scotland. But their recommendations are, I think you heard their recommendations on Tuesday, in that their recommendations are adaptability, and and it's for each local authority to take their view on that. So and we support
Did
that
I just pick you up right that in this part of Scotland their recommendation is 44%?
Yeah, but it varies, and there's currently new figures out, so it's UK SIP about to produce new figures. So it's a SEPA remit. It's not our remit.
Would you have any thoughts of a council planning a scheme with 0%?
I wouldn't have any thoughts on it now.
Thank you for that. Sorry. Can I just maybe turn to one or two other things? Just a second. In paragraph 418, and you refer to the Storm Frank peaking at Friars Cars at, I think, around 1:30. Would that be the same on the Whitesands then, or could that be a different figure?
It's not precisely possible to say, but it's going to be about that because of because it's flow. And because that's what our modelling has generally shown. It's about the same SEPA curve. That was about the case. Our modelling at the time predicted it was a little bit less, but SEPA came in with those estimates, so we weren't going to argue over it. So we accepted that. Yeah.
No, I was just trying to find out if it peaks at one part of the river, is that all the way down consistent, or it will vary, I would assume. Yeah. Okay, thank you. And then when Storm Frank at 1:30 comes down past the Call, past Evergilla Bridge, and meets the tide, or doesn't meet the tide, so does it depend on what time of day, or you take the measurements or whatever? Could you tell us just a little bit about the tidal influence on that?
Yeah, there is tidal influence at Whitesands, and there was indeed in 2015 there was some tidal effects there, and you do, obviously when you look at the SEPA record, you see tide in that record. At Whitesands, obviously you see tide in that record. But during big fluvial events, big river events on the Nif, the flows down the Nif swamp the effect of tides. So it's the flows in the river that dominate the peak flows in the Nif. So when it comes to trying to predict the height of a defence, it's actually the river flow that is the key parameter that we've got to, in terms of trying to understand the hydrology. It's the flow in the river that's the most important parameter to get right. In order to understand that, that's where the sensitivity analysis that SEPA referred to on Tuesday that we've done downstream to check that it's not a significant factor, and that's what we did, and that's good practice to do that. So we've followed that to make sure that we haven't underplayed the tidal effect, and that's proven. We've proved that to be the case. That's not to say there isn't tidal effect. It's just to say that it's generally swamped by the river flows during upflow. Yeah.
I did just notice in paragraph 420, I don't want to go back to it, but you said that the results from the recalibrated model gave reduced design levels. That's what triggered me asking about that. I think it was that statement. So, and that might help if you're looking later. In terms, we've heard a lot about 1 in 100 and 1 in 200 year models being used. Are you ever aware of a 1 in 200 or a 1 in 100 or even a 1 in 75 flood on the River Nith?
Well, the record's not long enough for us to know that. So this is where I guess the simple answer is I wouldn't know that. But I think that I'm not sure where that question's going. But what I would say is, in terms of the hydrology, and I'll just relate back to Alistair Moyer's presentation yesterday about how the hydrology tries to capture local knowledge, is that there's a recognition that the hydrology has to capture that records are short, relatively short. Records on the NIF go back to the early 60s, so there's a recognition of that. So the methodologies, standard practice, SUPA's methods, EA methods, etc., UK methods, which go back to UK methods and understanding this go back a long way, guide us and tell us to use data from across the UK to enhance those records. So we're required to, as hydrologists, to go out and build those records up. So we've got roughly the equivalent to about 500 years of records. That's what they try and encourage us to do, to try and supplement the local records as far as possible with records from across the UK. And that's what we endeavour to do in our analysis. So although I may not have seen a 1 in 75-year event on the NIF, although who knows, December 2015 may turn out to be that way in years to come, we've endeavoured to try and do that by using the guidance that SUPA and EA have with us right now.
I mean, the point of my question is I understand models, they're useful guidance, that you have to do these things, but models on particular locations should bear relationship to reality. And if a river doesn't flood to a 1 in 200 level, or a 1 in 100 level, or a 1 in 75, or even a 1 in 50 level, if that very, very rarely happens and would be catastrophic, these models then, I wonder about the value of them.
What's your specific question,
Yeah,
Mr. Dyson?
Not be more appropriate in terms of the locality of the River Nith if we were using models that we really wanted to learn from or really related to the river, that we would be using something like a 1 in 20 model instead of a 1 in 200.
I don't think so. I think it's the same model. I think it's the same issues. We've got to extend the records. We extend the records. No, I think the answer is no.
This is, I suppose, the Nunham question, okay, which we should spend a little bit of time on, I think. I mean, you're quite clear, I think, in stating that the design model that the council have come up with does increase. I'm picking this up. That it does create these increases. You've indicated in paragraph 510. I'm clear that
what I'm clear is that when the first alignment was presented to us in 2013, the model predicted those increases that I've indicated in my precognition, and that as a part of a design process, that the modelling was used as a part of that process to understand how we could mitigate for those effects.
We get to paragraph 513 where you say that the removal of the vegetation, etc., at the bridge will sort of mitigate that adverse situation. Your model tells you that, okay. How convinced are you that that will actually be the case?
Well, I'm here as a modeller, as a hydrologist. So hydraulically, I can tell you that it's a hydraulic solution, so provided the assumptions and the solution that is proposed as a part of the order and as a part of the scheme that is put forward as a part of that paper that is written into that option is implemented and maintained, then the levels that we have predicted will be sustained. So I'm confident that they'll be sustained.
So, because the people of Nunham obviously will be very concerned. They will be based. They will be looking for your assurance on this. And the worst scenario would be if your model was wrong on this one, because that would then increase things at Nunham. But you're absolutely 100% satisfied that your modelling in this case is right.
I'm confident in my model, as I've said in our report.
Could I refer you just briefly to paragraph 6.4, the very last paragraph? You say there that the proposed scheme would actually result in water level reductions in Nunham. Picked that up correctly?
Yeah, there were some reductions in that noted in that paper. Yeah.
And that was for all models or all return periods. So the Nunham people will be very happy with that. I would think then that the council's design will actually reduce the levels at Nunham, and you're fairly certain of that.
Well, it's not for me to comment on how the Nunham people might feel about it, but we presented the paper, and the council can process those results again.
Could I just finally pose a question? We do a lot of internet thing, and we've got a lot of people with questions out there, and I have had an engineer who just, and it's a question I wanted to ask myself. So, one of the things that we're keen on is rejecting the scheme, having it rejected. So the background to this question is that assuming the scheme was rejected, given your experience with SEPA, if options other than that which is proposed here today after this inquiry, what would be the best approach for the highest collaboration between the Council, SEPA, Scottish Water, electricity suppliers and the community? What would be the best approach assuming the scheme was rejected?
Mr Dowson, I'm not sure that's a question for this witness. No. Thank you, Mr Dyson. Mr Jolly, I hope you don't mind if you would bear with me, because I have a few questions that I think would help myself and Mr Jackman in writing a report. First question does actually relate to the Nunham issue. What I'm interested in is, after the initial removal of sediment at the Devergilla Bridge, how easy would it be to identify the point at which further sediment removal would be required in order to avoid the situation where water levels start to increase at Nunham?
There was some work done on a trigger level at which the council would have to go back in to remove, to maintain the dredging. I don't have that work on the desk in front of me right now. And that, I believe those results were provided to the council for information. And again, further that work could be more detail on that could develop as the scheme progressed. So, sorry, is that I've lost my own train of thought as I've been talking.
I suppose in terms of the Scottish ministers being satisfied that this is a matter that can be controlled, I'm wondering, is there some information we can rely on somewhere in the submissions that relates to that matter?
It's not in my precondition. I was.
Okay, I don't want to put you on the spot.
I wondered if it was important.
Could I maybe put it another way?
Yeah, go on.
Just as a hydrologist, how easy would it be to identify the point at which you needed to take material back out? Is it something that quite simply could be seen by a maintenance regime, by a look and see, or is it more complicated than that?
Well, from a hydraulic point of view, it's reasonably straightforward. There are other components to it, engineering and access and health and safety and practicalities to it, which others are better qualified to respond to than myself. But purely from a hydraulic perspective, it's fairly straightforward to determine the appropriate measures that trigger the factors that we know will lead to will impact on river levels at Nunhoe.
And would a visual analysis of the site be able to identify that?
Yeah, very much so. I mean, this is done at many structures. It's not unusual in that respect.
Thanks, that's helpful. One of the questions that has been put to us in the objections, don't know whether you're the correct person to answer this, but it's asking whether or not an allowance has been made for spring snowmelt. I'm not sure whether that is just something that's integral to the modelling information and the levels that SEPA have on record, but are you able to answer that question?
Yeah, I saw that one. It's just implicit within the hydrology, and snowmelts are part of the events that come down from the catchment, and because we're using data for ice casts, etc., it's implicit within the data that we're using, although people couldn't see that because they necessarily couldn't see some of the detail perhaps, but it's implicit within the hydrological data that we're using. And I can point people at references, but I can if people are interested.
The hydromorphology assessment talks about upstream flood embankments within part of the reach of the river being a source of the gravel that is likely to be deposited at Whitesands. And I'm just wondering whether or not any changes in the sediment regime upstream is likely to have any long-term implications for the flood protection scheme, or has that been built in?
Yeah, I'm not a hydromorphologist, so I'm going to have to refer that to council for another.
I had a sort of related question about the morphological environment of the river not being continually static. Is that something that you'd be able to address? Or again, is that one of the other witnesses who could comment on these sorts of questions?
If you ask the question, I can tell you. There's always a hydraulic aspect to hydromorphology, but sometimes it's.
Okay, the report talks about the river not being continually static, and that it notes that further up the catchment the river is active, and that an active section of the Clydden water and the close source of sediment has the potential to affect the morphology and extents of the scheme that's proposed. and that sediment deposition could trigger morphological channel change and pose a risk to the flood protection scheme in the longer term. What the report is saying is that such changes should be monitored. I'm just wondering whether or not those potential changes have been taken into effect, and whether or not there needs to be some control built in that requires the future monitoring. What your view would be of that?
Well, I think the issue of generally the issue of the flood and water in general. I mean, those floodplains are all included in the model itself. So hydraulically, it's all captured. There's, in terms of sediment coming down the scheme, if you like, then again, that's beyond my remit really to talk about. But it's the same issue, that it comes back to the very first question that you asked, really, in terms of at what point do you choose to remove, at what point do you choose to intervene and do the council choose to remove sediment at Devagila Bridge and maintain the bridge? And that's all it comes down to, essentially, to maintain the capacity of that arch and irrespective to some extent of what's happening upstream. So it's an issue of where they monitor and how frequently.
Mr. Cullen, I'm not sure whether there is another witness who would be able to sort of comment on the hydromorphological aspects of the river and whether or not there's a potential impact on the scheme.
I'm not sure that there is, ma'am, but I'll ask at the break.
Similarly, the last question it had is that the report also talks about the removal of the gravel bar downstream of the weir wouldn't affect water levels in major flood events, but it would help provide stability in front of the river wall, and that post-construction of the scheme, monitoring should be undertaken. I was just wondering whether or not, in your view, the removal of that feature to protect the river wall should be an integral part of the flood protection scheme, just from a strictly hydrologist point of view.
Yeah, I had no comment on it structurally, but hydraulically, it had no effect on. We rejected it as a standalone option, as I commented in my recognition, and so the removal of that gravel has no advantage to. Gave no advantage to. Was not a viable option on its own.
I suppose it's gone back a bit to one of the points that Mr. MacLeod raised yesterday. He commented on the river wall not being in any imminent danger, simply because the report is recommending that scour monitoring be undertaken. I was just wondering how crucial that might be to the flood protection scheme, or is it an entirely separate matter?
I don't think I'm able to fully comment on it, really, in the sense that with respect to the hydraulic modelling that I've carried out, once we excluded that as an option, we no longer looked at the dredging of the berm.
Okay, can I just move on to the one last question that I have? The previous witness, Mr. Swift, had mentioned that this might be one for yourself, and it was really just to clarify if the comments that have been made in relation to dredging about the minimal 2 to 61 millimetres reduction in water levels, is that range of reduction covering all flood events, or was that for a specific flood event?
So we looked at the dredging scenario we'd looked at was the 100 mil. We'd looked at 100 mil, reducing the bed by 100 millimetres, and that had been looked at in the. I think you find the results for that in the 2017 report, and that was just for the that's for the 1 in 25 year and the 1 in 75 year return periods. I think you will find the results for. So it's not for a wider range of return periods.
I think it would be helpful if you could pinpoint that for us, if that's at all possible.
I just might speed it along a little. I'm not sure whether this witness has the January 2017 hydraulic modelling report, which is SD4, but it's dealt with in there on page 38.
Yeah, is that the dredging one you're talking about? Yeah, so that's ST. So it's actually the 1 in 75 year was given for that in that report.
Sorry, I haven't got to that page yet, but you're saying that it was just for the 1 in 75 year flood event? Yeah.
I think it's just the 1 in 75 year, yeah.
I'm perhaps cutting across your questions, but in the same document, now that I discover the witness has it, there is a section 8 on freeboard and flood defence levels, which starts at page 53.
That's very helpful, Mr. Cullen. I'm quite happy with that. That's me finished with this witness. We've no further questions, Mr. Cullen.
Well, I was just going to ask the witness to turn over a few more pages and get to the section in the hydraulic, one of these scheme document reports, which is the section on freeboarding. You were asked questions about what impact it had and so on and so forth, and how it was dealt with. Is that set out in that section of the report? Page 53 of the January 2007 hydraulic modelling report.
Okay. Yeah, so section 8 of that report is a fuller description of what I spoke through, and table 8.2 then gives you the freeboard that I then set out in my response to you, which is the specific numbers, and those numbers, the calculations that underlie those numbers are based on the EA methodology that I explained to you, and that is just the method is described to you in that section 8 if you want to go back to methodology. Yeah.
You probably don't have that document in front of you. Yeah.
But that's SD12, that's it.
Are you happy for me just to note what they say just now, just for the benefit of Mr. Dyson? The figures in that table are ranging from roughly 0.7 to 1.1, very roughly.
I have that as scheme document 4, but it may be elsewhere as well.
Is that 0.7 of a metre to 1.1 metre? Yeah. Could I just ask, that sounds more than the SEPA recommendation?
Yeah, it varies across the scheme.
Thank you.
Mr. Cullen, do you have anything further?
I have nothing further for this witness, thank you, ma'am. I have an outstanding question to get you an answer to about the way this all related to reduction in height of defences, to which I suspect that the answer, rather like freeboarding, isn't freeboard was X but here is a table showing some freeboard values. But I want to check that before I give any information to the inquiry.
Okay, just before we break for lunch, we've made reasonably good progress again this morning. Obviously don't want to go on too late tonight, given that there's people have travelled, some people have travelled from a distance. I'm just wondering what the likely timings would be this afternoon if we do take 2 witnesses, or whether it might be a more reasonable prospect to look at a single witness this afternoon.
Well, what I can say, just by pure convenient coincidence, is that Mr. Callender happens to be one of the witnesses who is based locally here in Dumfries. So returning on a different date is less of an issue than those who've got to come from a distance. So if we simply did one, it wouldn't be an issue, I don't think, for Mr. Callender to return on another day.
Mr. Dyson, how long do you think you would take to deal with the 2 witnesses this afternoon, which would be Mr. Sharp and Mr. Callender? Yeah, that's what we did talk this morning, but potentially taking 2 this afternoon. How long would you anticipate taking in cross-examining both of those witnesses?
Right. Just give me a second, please, to think about that. Wow.
I'm really just looking for a reasonable prospect. Is 1 witness or 2 witnesses more likely this afternoon?
Well, I think we could do Mr. Sharp fairly quickly. I would work very hard with us all to try and get both done if that's what you wish to achieve. But I'm happy either way. I think Mr. Sharp would be less time maybe than Mr. Callender, but I know that's not very helpful.
Okay, well, we'll see how we go after the first witness and perhaps review the position then. What I'll also do this afternoon is have a quick discussion about the proposed accompanied site visit locations too, and just to see whether we can firm this up a bit and get the details issued to the Morton Fraser and Dunholm residents over the weekend. Okay. So if we have a break now, if no one else has got any points to raise, we'll have a break now and come back at 1:25.
Ma'am, just to say, we did send those out, including to Morton Fraser last night after the hard copies had been given out here. So they will have had them. We haven't heard anything from, back to us on that.
Yep. Thank you. Mr. Connell, could you
Yes,
please?
thank you, ma'am. I want to touch on a couple of things just before we resume with the next witness. First of all, there are 2 questions outstanding, I think, from this morning. First of all, the reduction in height of the defences following recalibration of the model. Now, I don't have a convenient, neat piece of paper to hand over, so if you just bear with me while I give you a couple of sentences, and then if we need further material on that, we can follow that up in due course. The position I'm advised is that the model doesn't set out to dictate reductions in defence heights. The model simply produces the model results of the water levels after the recalibration. It's then a question, in any case, just taking it generally, for the client to decide, in light of that recalibrated set of figures, what steps to take to reduce levels. So that's why, in a sense, it's not just lifted from the modelling material. In this case, I'm advised that the decision was taken to reduce defence heights. The precise reduction in defence heights varies depending on which cross-section you look at, because there are different, for instance, riverbed characteristics at any particular point. In general terms, the reduction in height was in the order of 400 millimetres. There was a reduction at one point of 750, but that was exceptional. That's the information which is readily transmissible to you, as it were, in this moment. If it's thought in due course, and we don't need to do this now, that something further is required or a document is required, then of course we can make arrangements to provide that. But I wanted to provide that information in answer to the question that was held over. So that's one. The other question was in response to your issue, ma'am, on the hydromorphology. The first obvious answer is that the Council haven't come equipped with a hydromorphology witness because that issue hadn't been flagged as one that this inquiry was expecting directly to hear on, beyond the documents that were lodged. If the thrust of the issue focuses on what might be described as impact on maintenance of river walls, then the Council's position, as I think was stated yesterday, is that they maintain the river walls, they are obliged to maintain the river walls, they will continue to do so, and they will, of course, in that process, look to any changes which might affect that regime in terms of impact on the walls. And therefore, if that is the issue, the Council's position is that nothing further is required in this particular process to deal with the question of, as it were, keeping an eye on things which might affect the river walls. If there is a separate freestanding issue about some particular monitoring or something which is said to relate directly to the flood protection scheme, then the suggestion from this side is that rather than endeavour to deal with this on the hoof, as it were, the best thing to do would be to defer that question to the modifications and conditions hearing session at the end, and if after reflection it is thought that that should be on the agenda there, then notice can be given and we can all be equipped to deal with it. So that's the two questions.
Thanks very much, Mr. Connell. Mr. Dyson, are you happy with the first question being answered here, and you don't require any further submissions on that matter?
Yes, I'm very grateful for the efforts that have gone in there to helping me with that, and thank you for that. Yeah.
And in the second matter, it was something that I'd raised with my intention of raising it potentially in the second hearing session. So if we can perhaps come back to that in terms of any conditions that may be required in relation to monitoring or implementation of further works, then I'm quite content to deal with it there. But we'll take a view on that.
The only other thing, ma'am, just since we're dealing with housekeeping, is you asked for an update on arrangements for next week. If one was to assume, just for the sake of argument, that we stopped after dealing with Mr. Sharp, just as a stab at it for the moment, that would leave Mr. Callender and Dr. Chatterton as the last technical witnesses, which would be Tuesday. And one can make a stab at that and perhaps say Tuesday morning or thereabouts. That would then take us in order into the visual design, townscape, heritage section. I'm conscious that Mr. Dowson has evidence to lead under that banner, and therefore we need to consider that possibility. If one was to assume, for the sake of my response, that Mr. Dowson is able to deal with that matter in terms of witnesses, that immediately after we finish technical, then perhaps we're looking at, for the sake of argument, possibly Wednesday for the Council's witnesses to start on that topic. And I have been able to make arrangements for witness availability for Wednesday and no doubt for Thursday as well if required, I think. I'm slightly uncertain about order because witnesses have indicated commitments, and I may need to juggle depending on what we decide today.
Mr Dowson, would it present you any problems in bringing the sessions forward by a day?
It doesn't present a problem for me personally. I think I've got one witness, Felix, who I'll just need to check his availability. But assuming that he can manage, we'd try and go along with that. But I will have to check that.
What we'll do is we'll take a kind of final view on that. Perhaps when we finish today, we'll see whether we'll get through Mr Sharp. Okay. Having spoken with Mr Jackman, he thinks it's probably a better position to finish after Mr Sharp today. Okay.
And then, so what, just to clarify, so let's just work out the programme for next week. So if we can start on Tuesday morning with the two outstanding council technical witnesses, and then whenever that finishes, which could be Tuesday afternoon or possibly Wednesday morning, you lead, Mr Dowson, and then if Mr Waterhouse is local and can do that.
He is local, but I will just have to check with him.
Now, in worst case, if he wasn't available, I don't have any objection mixing the order up if people are around.
If it's a question of slotting Mr Waterhouse in at a convenient point to suit him, then there would be no difficulty with that on this side either.
And what that means in practice is that we've probably got Friday as strategic reserve. And I'm a great believer in having strategic reserves. But like Napoleon, I don't like using them. And so that seems a plan next week. Okay, great. Thank you.
I'm going to hand back to yourself, Mr Connell, but I'll come back to the point of site inspections when we're finished with Mr Sharp. Okay, thank you.
Certainly. So we'll work on the basis that we'll seek to bring the three, I think it is council witnesses from Wednesday. I think that's probably a logical target. So that, and then we'll judge the order once we see how things go. It's me again. I now have to introduce Mr. Sharp, who is the man who deals with the Scottish Water Network and other associated issues. He has produced a precognition. Now, the start of the precognition, of course, Mr. Sharp, you set out your various qualifications, and I suggest we take that as read. You've got a CV at the back. We'll not bother asking you to read that out either. And we'll move straight, please, if you go to section 2 of your evidence. Can I just say, ma'am, for the purpose of this session, it may be that there's value in actually having a document available. We've been trying to avoid too many cross-references to documents for sake of speed, but there is a discrete section in the materials which is called the I forget what it's called, but it's headed Scottish Water. It's the Solution Development Report in terms of a labelling, and it's number 26 in the bundle. It's a fairly discrete collection of materials solely focusing on the issue that Mr. Sharp deals with.
26.
SD 26. Sorry. If you could just... So, Mr. Sharp, if you could turn to section 2 of your recognition and just start us there, please.
Hello, my name's Rob Sharp. So I'm going to give the scope of the evidence today. My evidence on the inquiry focuses on the drainage aspects of the scheme. A number of documents have been issued to you. They're there in the list, the key documents we refer to. So mainly to do with the Lower Burn, Middle Burn, covered water courses, the surface water drainage system, and the, sorry, I'm jumping ahead of myself. The documents are provided. The evidence I prepared and provided this inquiry is true and has been prepared and given in accordance with professional standards. I confirm the opinions expressed on my true and professional opinions in providing expert evidence to the inquiry. I'm aware it is my duty to provide my honestly held professional view. So my role was first introduced to the scheme in 2011 and remained with the project up to the submission of flood protection order. My role as drainage design lead was to coordinate, plan and deliver the drainage design of the existing drains and sewers that would be affected by the construction of the flood defences. Following commission, we identified that there were 3 separate sources of potential pluvial flooding. That's flooding caused by rainfall, as opposed to the fluvial flooding which is caused by the river. It was agreed that Michelle would compile 3 separate reports to address each of these issues. The 3 sources we identified were surface water drainage network, the Scottish water sewers, and the Lower Burn and Middle Burn water courses. So I'll deal with each of these in turn. So the surface water drainage network. The existing highway drainage currently discharges to River Nith via gravity networks to outfalls on the river wall. The scheme includes a redesign of the highway adjacent to the flood defences, and as a result, new drainage would need to be designed to suit this new highway layout. Further, following high river flow conditions when the river level rises, the flap valves in these outfalls would close and will prevent surface water draining into the river. Thus, there will be a build-up of surface water behind the flood defence structure, and this runoff volume needs to be managed. A new drainage system is required to control the volumes of surface water flow generated behind the new flood defences for both normal conditions with the outfalls operational and with a flood condition where the outfalls are closed. Michelle was instructed to assess the issue and provide the recommendations, and this work is detailed in the Surface Water Drainage Strategy Technical Note, January 2017. Both the existing drainage network and the new areas will be drained directly to river. To be drained to the river were identified. Once that had been completed, a hydraulic model was then used to determine the flood volumes and flow rates for the 130-year event, which were then in turn used to assess the works required to address the effects of the surface water runoff when the river levels are high and the outfalls are blocked. This 1 in 30-year no flooding criteria is commonly used as a standard level of protection to property and stated in the Sewers for Scotland design guidance.
Can I just ask you, Mr. Sharp, that 1 in 30 year, that's taken from sewers and water guidance, not from guidance which is related to flood recurrence events. Is that right?
That's correct. It's to do with developments. Yeah. Yes, as I mentioned, the pluvial flooding, rather than the fluvial. Yeah. There are several options to deal with the surface water runoff. Passive methods, including allowing the water to pond on site, provision of above ground in dedicated areas or underground storage, and active methods, namely pumping. The report recommends that the storage solution is taken forward for detailed design. The main benefit of this option is that it's a passive system which doesn't rely on human interaction or electrical and mechanical devices. Additional benefits are that the construction costs are lower, the design life greater, and there are less running and maintenance costs than other options. While doing this work, we were considering SUDs, which, as you know or may not know, is Sustainable Drainage Systems. So the SEPA was consulted to discuss the SUDS requirement for the flood protection scheme. As the flood protection scheme was developing an already developed area with an existing drainage system, SEPA advised integrating SUDS here would be good practice. They also advised that discharges would be into the transitional waters below the call. There were no legal obligations to provide SUDS. Guidance in SUDS is set out in the SUDS manual, C753. The Syria manual puts forward a risk-based approach and a simple index approach to be followed using an online tool to determine the type of suds required. It was felt that improvements to water quality could be provided as part of the scheme, and to that end the SIA spreadsheet was caused to quantify the improvements that were being considered. Due to the high groundwater levels, infiltration techniques, normally infiltration trenches and mill paving, are not suitable, and other systems as biocells, storm cell storage and vortex chambers were considered appropriate. It was recommended that treatment provided to improve the quality of the runoff, vortex separators to be installed on the outfalls into the river, as these will remove silt and other pollutants. The use of biocells is also recommended, using the trees that will be planted as part of landscaping works.
And now you're coming on to the issue of the Scottish Water Network, is that correct?
I am. So we've done sort of highway drainage and the rainfall that falls on the rear of the fences. So now we're looking at the Scottish Water Sewer Network. So the proposal to install flood defences in the Whitesands area led to consideration of the existing combined sewer network, which is also connected to River Nith. The existing combined network that serves this area is owned and operated by Scottish Water. The required level of service for them is a no flooding 1 in 30-year rainfall event, as stated previously. This is the guidance from Sewers for Scotland. The most up-to-date Scottish Water hydraulic model of the area was obtained, and the extent of the predicted flooding determined. This model predicted flooding from the combined sewer network in the areas of Whitesands, Brewery Street and Friars Fennel. The outcome of the investigation and the proposed solution was outlined in a report entitled Whitesands Flood Protection Combined Sewer System Option Assessment Technical Note. An additional note was then prepared, issued to the Council in June 2014, with the recommendation that this report was that Scottish Water be presented with it to ensure that they were aware of the existing combined sewer issues and the need for further liaison. Further to Scottish Water receiving the report, 3 technical workshops were held over a period from October 2014 to February 2015 with Scottish Water, the Council and Rochelle. At these meetings, the operation of the network was discussed, the suitability of hydraulic model was addressed, and the river level information was reviewed. A final meeting, held in August 2016, to discuss the findings of previous reports and to appraise other parties in Scottish Water for proposed works. The actions taken from this meeting have been addressed, and Scottish Water stated they were satisfied that the model predictions provided an accurate reflection of flood risk within Whitesands. The outcome of this meeting were included in the report, the Solution Development Report. Options for the proposed interface between the scheme and the drainage network have been analysed, with a preferred proposal involving pumping stations to prevent flooding from the combined sewer network. Scottish Water has agreed to this proposal in principle. And SEPA has been consulted regarding this option and has no objections. So in the third part of it, my works were the Lower Burn and Millburn drainage network. So 2 culvert watercourses, Lower Burn and Millburn, which are located centrally within Dumfries, to the north of the River Nith, discharge into the River Nith, approximately in line with the junction of Nith Street and Whitesands. In 2013, it was proposed that a pumping station be constructed to allow the watercourses to continue to discharge when the outfalls were closed. A review of the available data concluded there was insufficient information to determine the extent of the works required. Prior to preliminary on detailed design, was recommended that further survey work be carried out to confirm the level of Millburn and Lowerburn from the outfalls up to the source of each culvert or watercourse, in addition to all contributing branches. Work was also required to investigate the location of the pumping station and physical constraints that would affect this. Further to collation of the additional information, including CCTV and manual surveys, in September 2014, a final report was produced that allowed the pump solution to be developed. It's called Whitesands Project, Lowerburn and Millburn, Operational Review and Option Assessment. An empirical method of analysis was used to determine the potential flow in the Millburn watercourse. The maximum flow within the network is dependent on the capacity of the pipework, and recent survey information was used to determine the drainage network in the downstream area, and only verified information was used to determine the design flows. The proposed option is to connect the existing drainage network at St Michael Street to a new pumping station. In the event, or in an event, where the flap valve of the outfall is closed due to high river level, the flow will surcharge in the pipework, spill over at pipe flow level into the pumping station, from where it will be pumped out into the river. The new works will be a bifurcation chamber where the flow can be split, connecting pipework, a new pumping station, and discharge pipework to the river. And it's proposed that the new pumping station be located in the footway area to the northwest of Nith Street. In preparing for this inquiry, I've been through some objections that have been prepared have been compiled and issued to me. There are some comments I'd address back to those. So there were comments on the existing drainage networks, and some objectors have commented on the need to address the existing drainage systems. And I believe I have addressed these points in the reports I've prepared and have summarised in the preceding text. I've identified the relevant drainage networks and have produced proposals to address their operation. Other people raised objections about the involvement of Scottish Water in the drainage design process. We've been working with Scottish Water since 2013, and they've been vital to the development of the proposed works. SEPA involvement, again, some objectors have commented on the involvement of SEPA. We've been working with them since 2016, and they've been vital again in the development of the proposed works. Other questions asked was what about the cleaning of the Whitesands if overtopping occurs? So the response to that would be we've advised additional drainage pipes be installed at the base of defences to allow any water that's behind them to drain away quickly, and that's covered in the reports. And that's the end of my pre-commission. Thank you.
Can I just ask you then, just so we're absolutely clear about that last point, because the idea that if the defences were overtopped, large quantities of water would sort of be trapped behind the defences. Is there a drainage solution proposed for that?
Yes. Any water that falls over the embankment, the berm, the wall, the defences, on the dry side will either return when the river level drops and the gullies serving the highway drainage would run out. In order to help that, we propose at the bottom of the berm there be pipes running above the ground level which will allow the water to flow backwards. I think that's common practice elsewhere. Thank you.
The other point that I have for you relates to the extent of the involvement of Scottish Water, which you've touched on briefly in your report. Now, I think you have there the Solutions Development Report, which has been lodged, which is SD 26. That contains, I think, quite a lot of detailed drawings and discussions of network details. Is that correct?
That's correct. I was surprised that the Scottish Water involvement was seen as an objection whenever the report had been issued, and the extent of the discussions included within that.
And just so we're all absolutely clear, Scottish Water were a party to all of these discussions that are contained in that document?
Yes. This document you see here is the ultimate sort of sign-off that Scottish Water have. We met with Scottish Water operations people, development people, the local people we met, the planners, the flood managers, people within Scottish Water who've got an input into this kind of thing. Thank you.
Thank you. I have nothing further.
Mr. Dyson, do you have any questions?
Yes, Mr. Sharp. Thank you. Could I just ask you a kind of historic or global kind of question about the BABTI report? You're presumably aware of that, the part 2 of that.
No, I'm not. I'm addressing the situation as it now stands, not something that happened 30 years ago. Okay.
I see. Right. Okay. Right. That's disappointing, I must say. Okay. Okay. The do you are we aware of any cost estimate, or the global cost estimate for the works that Scottish Water would require to do as part of this whole scheme? Do you have a figure? Yeah. Yes.
Am I aware, or are you aware? No, am I aware? Yes. Scottish Water gave us a high-level cost estimate. Was it early 2017, possibly, for the works identified in this document, which I think you stated there was no Scottish Water scheme, but the scheme has been modelled and covered in this report. Okay.
Could you tell us what that figure is?
I think the construction works were 1.2 million, and the contingencies and other extras were 1.8 million. when we asked them for some more detail on those figures, they were a bit vague. Certainly a graph which just showed the figures, but we didn't change the figures, and I didn't change those figures.
Can you tell me, were those figures provided by Scottish Water or by the council?
Like I just said, by Scottish Water. It was a high-level estimate by Scottish Water.
The reason I was referring to the Babty report, and I won't go into it if you're not aware of it, but in 1988, Babty estimated the kind of works that were required then at about 2.2 million. And taking that forward 30 years, I must admit I'd be very surprised if all the works that Babty recommended could be done for a total of 3 million. What I was trying to find out was whether any of the original Babty recommendations were now not being addressed. That was really what I was really trying to find out. But you're not aware of that, so no.
No, I can't comment on their report, and I can't comment how they built up their prices, and I can't comment on their level of agreement with anybody else.
Paragraph 4.6 of your recognition, where you talk about underground storage. Now, I've tried to identify where these potential underground storage units or tanks or whatever they are. I believe there's one in the DG Holmes car park site, or proposed. I'm just trying to identify. This comes down to the detail part, which I've struggled with a bit. Are there 2 or 3 locations for these underground storage tanks?
Okay, so that section you're talking about refers to the surface water drainage network. So this is to address the rainfall that falls on discrete areas along the front, which are affected by the works. So when rain falls in these particular areas, it used to, as I said, run out into the river, but now it may not or cannot run in the river when the river level is risen. So the proposal is to put in some called geocellular units, and they're identified on page 5 of the document, Whitesands Flood Protection Surface Water Drainage Technical Note, which is SD20. So those are shown at 4 locations. There's Zone 1, Zone 2, Zone 3 and Zone 4 on both sides of the river. Whitesands from Buccleuch down to Assembly Street, from Assembly Street to St Michael's Bridge, one at Dock Park and one at Welldale, Kenmure Terrace. And they've been sized to account for the 1 in 30 year, which I mentioned, 1 in 30 year rainfall that falls in those areas which won't get into the river. So those 4 locations there are proposed. If they were to move a metre or 2 or 3 or 4 or 5, it wouldn't really matter to me. But they would need to be somewhere in the area that the pipework could connect into and connect back out again. So as for the actual location, they are indicative there at this stage in our design. But maybe further on might be moved due to accommodate services or other things.
Just a question about the capacity of these. In a sort of large rainfall or a long duration of rainfall, is there a possibility that these would become full, or is that?
Yes, it's possible.
And can you tell us what happens in that situation?
Yes, water won't go into it. It's self-evident that water won't go into it if it's full already. You design a storage, a 130-year design to store a 130-year design event. You don't design a 130-year event followed by another 130-year event followed by another. You don't do that level of design. You do one volume. You might get a 1 in 5-year event which might partially fill it, which make it empty, and then be ready for the next time. But these are transitory. They're not. It's not going to go in there and remain there forever. And as you see in my sketch on the same report, it shows water draining back out again. But in the event of a 130-year event, followed immediately by another 130-year event, then there will be flooding within the Whitesands area. Yeah, I mean, that's the level of protection you designed to.
Thank you for that. Yeah, I'm learning. I'm afraid this is not my subject, but there are questions that I did want to just be clear on. Thank you. Okay. I'm looking at specific locations, and Brewery Street has. Is there a particular problem in Brewery Street that I've spoken to people who have properties in Brewery Street who seem to think that there is a problem in that location. Are you aware of that?
A flooding problem? Yes, as I mentioned in the Scottish Water section of the report, the model predicted flooding within the combined sewer areas of Whitesands, Brewery Street and Friars Vennel. And during part of our works back in the early days of 2012, we went to site and did a comprehensive series of questionnaires, and we asked people where the flooding was, because we initially, when we engaged with Scottish Water, they didn't believe there was a flooding issue there. So we went out to get some information. So we spoke to Mr. Backey, who was here, Mr. Sherman, and several others, and we gathered information. Water coming out of gullies was mentioned, water seeping through walls, cellars that weren't used due to water ingress, and things like that. So, yes.
So you have a solution to that in your proposals, yes?
My solution isn't to solve flooding at people's properties. My proposal is to deal with the drainage for the rainfall that falls in behind the thing, and behind the defences. It's not to solve individual flooding to properties.
I take it from that these properties will still suffer then?
She'll turn it on. There would be no change, as far as I can see. If the issue is that the water, however it gets there, is caused by whatever cause, we're not addressing that issue, part of the scheme, and it may still be there at the end. I couldn't say.
I'm aware, and we have submitted a document, an email from Scottish Water to the Council, dated, I think, December 2016, in which they stated that they didn't think the designs were detailed enough to provide a costing, and that they could only give an in principle kind of nod to the designs, and a lot more work would be required. Is that your view of it?
It's not my view, but my view of it is that the letter or the email you referred to by Gillian Crichton is included in my documentation. It's Appendix B2 in my report, where Gillian writes as a member, a team leader. She's a team leader in Scottish Water's flooding team. And she talks about the scheme. She says currently there is insufficient detail for Scottish Water to comment fully on the proposed solution, but that's exactly true. It's at outline stage. We have worked with Scottish Water to agree a way forward. We have a solution to address the concerns of the flooding in the Whitesands area due to Scottish Water sewers. And at this stage, we've put forward some proposals. A number of options were considered and proposals identified, and she's commenting on that. But we haven't crossed every T and dotted every I. But in principle, they are behind the solution. And when we speak to the operational people on site in Scottish Water, they're behind it as well. They understand the issues with their own network, and they see that as being a solution that will work for them.
I think if you go further in the email, though, they do refer to not being able to provide costs.
Yes, if you read that, it says Currently, there's insufficient data to comment fully on a proposed solution combined. Yet they have. What can I say?
Yes, I just find it interesting that they say there isn't enough detail for them to provide costs, yet we have effectively a £3 million cost. The two things don't seem to quite match up.
I think it would be better if you'd address that to Scottish Water when we met them on Tuesday. They could tell you why they wrote this and then why they wrote the subsequent email.
If I can reply, I did address that off inquiry to them, and they effectively said that nothing had changed and that they still couldn't really provide a detailed cost. Could we just have a look at the Lowerburn and Millburn drainage network? And can I just say that there's an awful lot of local interest in this because the historical significance of these two burns. Could you give us just a wee bit general comment about basically the actual course of the Lowerburn and Millburn and the confluence of them, where they actually come together, and anything on the connections of both with culverts and sewers and the condition and capacity of them?
Can I maybe ask Mr. Dowson to frame that question a little bit clearer? What is it specifically you're looking for?
Well, I'm looking. I'm looking for just a general description. That I think part of the problem, I am asking for a bit of help here, is that there seems to be, although these are historically there and have been for a long time, there's in fact very little information about some of the courses, whether the Lowerburn does in fact, where and when and how it actually goes into the Millburn and so on, and what kind of capacity it's at. I suppose my question is, do you have good data about that, or would it really be better to have a much more detailed research, and could that be done?
Okay, I thought I'd addressed that in my previous mention, but I talked there about how initially it was sort of modelled, but then when we realised there was a shortage of data, we went to an empirical method. Yeah. So I'd just like to refer back to my report, the Whitesands Protection Scheme technical note, where I provide some background to the covered water courses, which we noted as being a live water course and water continually flooding running into the river.
Is that SD19?
Yep. So we needed to address that, so we went on to do some research and found some drawings. Figure 1 in this document is extracted of Dumfries, Shear and Galloway Natural History and Antiquarian Society's transactions. I'm sure you're familiar with that. So it shows the Millburn, the Lowerburn coming together at a location. I think it's is it Cumberland Street, potentially, possibly. And we used that to start our manhole and CCTV surveys to try and using that as a guide to where the route was, backed up with some local knowledge. So we went out and lifted manhole covers and did some research, and we took it and went up as far as the Morrison's car park. The name of the road escapes me, but we found it there, and water was coming into it, and we realised that we couldn't determine, which we normally do, is we would look at the catchment area, you would look at the pipe characteristics, you would assess an area to a pipe, you would work out the flows. We couldn't do that here because we didn't know what was draining into it, what was being picked up by surface water drainage, because the water is culverted. So courses are culverted, then where water comes from or goes to. So we based a solution on the information we did know, which was the survey of the bottom end of the pipes, bottom end of the system where the pipes come out. So the solution I'm proposing in here, I mentioned in this report, was that we weren't going to spend time going back, and it might take us forever to determine the exact locations and contributing areas. If we couldn't do that, we would look at the pipe itself. So when the pipe becomes full, water will spill over avoid flooding upstream, because we're kind of near that end. We're flooding in Queen of the South pub, so the cellar there floods, yeah. So water would spill over into a pipe, run down to wind pumping station and be pumped out. So when the river levels are up and the flat valve's closed, Millburn can't get out, this pumping system will work and will avoid flooding upstream. So it's an empirical method, and if there is very little flow in these, it'll take a long time to spill over and pump out, but that's what we based it on. Oh, sorry, could I just mention as well, I'm aware there's another water course mentioned within Mr. Miller's precog, and while I'm not aware of this in particular, the gutter of Colsey gutter, I would say that when we did our survey of the outfalls along the river wall, we assigned those to grids and to gratings and to Scottish water outfalls and to other, and we believe we picked them all up. So it might be that this historical gutter has now been subsumed into a sewer network, but I don't know. Again, Mr. Miller mentions that, and he said I think the words were something like this is of maybe more significant archaeological interest, I think he said. Yeah, it may be that this reason this work has been superseded. It is now of historic interest only, but I would suggest that if we find that during the course of our works, we will pick it up. Thank you. Thank you.
Down at that location of kind of around Nith Place, I did pick up in one of the, I think a comment from Scottish Water that even if the flood barrier is built to the council's specification and design, that there's a possibility of flooding still happening behind the flood barrier, and that could cause reputational damage to, I suppose, both the council and Scottish Water, because the public would say. So could you tell us a bit about that and how you would resolve that problem?
Yes, again, as we mentioned in our reports, there was this work. It's not something we've tried to hide from, so we put in the pumping station with Scottish Water's involvement to take most of the flows. However, there are certain areas which are different, and we can't get the flows from there into the pumping station. They need to be addressed separately. So I'm thinking down at the Dock Park, there was a note that some of the manholes were to be sealed down there. Again, this is common in low-lying areas where you may seal a manhole or two to stop water coming out in times of storm. And there was a comment, I think, Bob Fleming from Scottish Water, that if water was to pond around here, it would be reputational damage, and that's none of our interest.
Sorry, I maybe didn't pick you up. Have you got a solution? In the long run, are you confident you can resolve that problem?
Yes. The sealing of manholes, as I said, is very common. Water level will have to rise to about 7 metres, so about ground level-ish around there. That's probably limited times. So we expect to be fine with this.
Just with regard to pumping stations, I'm just trying to be sure how many there are actually proposed in this scheme. Could you just clarify that for us?
For the Lower Burn Millburn, there's a pumping station. For Scottish Water, there's a pumping station. And that's it. In the Lower Burn, in our surface water report, we had two options. We had 4 small pumping stations or storage, and recommended storage.
Can the pumping station still work when the river's in flood? And how do you get things from the pumping station past the barrier if it's built and still be able to pump into the river if the river's in flood?
Yes, it's fairly straightforward. You build a pumping main, which would be a ductile iron or some pipe work, which leaves the pumping station. We have a known top water level within the river, we know our depth of our pumping station, and we can work out what head we need to drive between the two. We work out the volume we need to drive and put a pipe through. The pipe can go straight through a wall. We'll seal it around the wall with a, don't get too technical, but a puddle flange. You put a puddle flange through it and you put it through, it will pump out into the river. When you go out to the river wall, in normal condition, you would see a flap valve sitting there. I think we talked about a 400 mil diameter, so we're talking something about that size. So we see two flap valves. When, in times of river being high, there'll be enough power in the pumps to pump up, open the flap valve and push it into the river. So it's not, it won't stop doing it when the river is there, it'll just push out into the river. So we've designed it to work at top water level. Again, that's fairly common. Or it is very common.
I've experienced in a number of floods, and I'm aware of power cuts, electricity power cuts. What happens there if if there is no power to the pumping station?
Again, that's a design consideration for all pumping stations. Pumping stations are powered by electric. Electrics is controlled in a kiosk adjacent to the pumping station. Those kiosks generally have sort of flap valves in the side, little cap flaps, where you connect in generators. So in the event of a storm coming, and in the event if the pumping station were to have a sudden power failure, you could bring in a generator. I think that's a thing that Scottish Water do all the time, have a number of generators on hand. The bigger pumping station is Scottish Water, so they would look after that. And the council would take over the running of the Lower Burn, Middle Burn pumping station. But an alternative power supply is what you generally prepare for when building a pumping station.
Just in the wider context, I assume that as part of the whole scheme, the council, Scottish Water, everyone works with the electricity agency to just try and look at the whole, power supply, because I am conscious that there have been a number of power cuts in that area at times of flooding and probably caused by flooding. So that would be part, presumably, of the overall plan, would it, to rationalise that?
I would expect so, but this will come out of detailed design. If you're doing a detailed design on the pumps, you'll be looking at the power available to the site. You'll be looking at risk of it dropping out, risk of losing power, and you'll be refactoring that in. But that'll be a detailed design stage. At this stage, a pumping station is being designed.
Just one last question, and it's going back to the costings and things like that. It sounds to me from what you've said that there's a lot of unknown things under there. If I can just put it that way, there's a lot more research needed. Would you agree that therefore there is quite a strong possibility that in the fullness of time that £3 million cost estimate might well be exceeded and might be exceeded by quite a considerable sum?
It may be exceeded, it may be reduced.
Thanks, Mr. Dowson. I think most of my points have already been answered. I just have one or two. The actual order itself lists the construction of the pumping stations, associated pipework, manholes, power supply, etc. Does the council's cost estimate for the overall scheme include that 3 million, or is that something, or estimated 3 million, or is that something separate?
I don't know. I haven't seen the council's figures for the cost of the scheme in breakdown.
That's fine. I'll leave it at that. One final question, I suppose. If we're in a 1 in 30 rainfall event or above, and the water would be designed to be pumped back into the river, could that potentially raise the water levels in the river with any significance and affect properties downstream?
Generally, it's not considered, but I think the volumes that we're looking at, we're pumping. I think our pumping rates are about. I think peak is about 400 at one pumping station, about maybe 200 at the other. So we're pumping back 600 litres per 600.6 cubic metres per second. I believe the one into a 75-year flows down there in the time of storm is in the region of 700 cube per second. So it's an infinitesimally small amount. And that water would normally run into the river, generally anyway. And coming down the Lowburn Millburn would probably cause flooding upstream, but it may be pushing into the river as well. So it's not as if we're making up this water. This water is within the system. You know, we're not generating water.
Okay.
Just, you talked about the 1 in 30-year design parameter that Scottish Water use. So that's a rainfall event. We've also heard about the 1 in 75-year flooding event. Are there any incompatibilities of these different parameters? Are they comparable? You know, does that cause a problem technically?
Not to me. I've used the 1 in 75-year level as being our level for our pumps to discharge to. I'm not really that concerned about what level it is. When we look at our pipe work and the pumping station operation, we look at the 130 because that's the level of protection that people need, deserve on the rainfall side, and that's what we provide too. We don't give them 175 because the other side of the defence is 175. So 1 in 30 is what everybody should expect, and that's what we give them.
And is it at all possible that, in terms of working up the detailed designs, Scottish Water would adopt something that they were unhappy with?
No. When the schemes come through built out, we hope, Scottish Water will be heavily involved in the design. The design will be to Sewers for Scotland, and there are Scottish Water documents, design standards, which will be used. I mean, I'm not sure who will be actually building the scheme, but whoever did it would have to build it in such a way that Scottish Water will be happy with the adoption of it, and as they be involved in it, with the requisite manual covers and accesses and kits and stuff like that.
And in your experience, is it a normal design process to, if you like, get agreement to a strategy or a concept, and then at a later date work up the detail, which could then be costed? Is that standard?
Yes, it is standard. Yeah, I mean, when we first proposed the idea, I think the local Scottish Water operatives said, "Well, you need a pumping station, won't you?" Pretty much as soon as we talked about it. We did look at other options. Again, the Solution Development Report runs through other options, or a do-nothing option, other various options, putting in several pumping stations here and there to resolve the issues. We didn't think that was much better. And putting in maybe a lesser standard of service wouldn't that either. So we worked on various options. So we do a preliminary design, outline design, get agreement with that, on that, and then move forward.
Mr. Sharp, thanks very much for that.
Thank
Mr.
you.
Connell, do you have any
I
final
have nothing
points?
further for this witness. Thank you.
Mr. Sharp, that's fine. Thank you very much. Before we move on, would it be possible just to spend a couple of minutes having a look at the site visit arrangements which have been circulated? Still anticipate that we would like to make accompanied site inspections on Tuesday the 4th and Wednesday the 5th. Mr. Dyson, do you have any issues or comments with the itinerary that's been proposed there?
Sorry, I apologise, I haven't really had a chance I'm sure I can be very flexible on that, so I don't think we'll have any issues.
You'd asked us to look at upriver embankments, including Dulscone and various locations. Are you able to firm up where you want us to look, what you want us to look at, and how we would get there?
No, no, I'm not. I noted that there was a plea, perhaps, not to actually do that, and I'm prepared to go along with that. We obviously we're still concerned. We are still concerned about the failure to do the upriver work. We feel that was a catastrophic design, bad design decision at a very early stage. But I don't think a visit would necessarily clarify anything. So we'll remove our request for that.
Thanks, that's appreciated. This is itinerary, obviously, thankfully been circulated by the council to the parties, including Morton Fraser for the residents at Nunham. We still haven't had confirmation back yet whether or not we can actually physically get access to the properties at Nunham that have been listed. So we will pursue that next week and hopefully be able to confirm the position with the planned visits on the Thursday by next week.
I'm just assuming, ma'am, that what has happened is it's gone to Morton Fraser and then they've sent it out to various individuals and they're waiting for somebody to come back and say, fine, not fine.
Could I just ask a question about the visit, the nature of them? As you pass through the town and various locations, that you may find that people might want to talk to you.
Be brave.
So I just wondered, is there a protocol? Could you advise us?
Okay, just for everyone's benefit, the purpose of an accompanied site inspection is to allow the reporters to view things on the ground and familiarise ourselves with the sites. As you know, we've been out already, we've walked the area, but there is a benefit in having an accompanied site inspection in order that the parties who do know the area better than we do can show us specific locations or things that they feel we need to see to understand the situation. But that doesn't involve discussion of the merits of any aspect on the site, and we wouldn't and couldn't entertain any debate and discussion on site. Also, if we are proposing to enter onto a private property, we wouldn't go mop-handed. We'd have to have the person's agreement in advance to enter the property, and the person would have to be present. So what we would do is we would also seek to nominate some selected parties from the representatives so that there was only one or two from each entering onto the site with us. Does that explain things? Yes.
I'm just taking it that you don't want to get into detailed discussions with all these people who are probably going to know you're coming.
If you could perhaps just explain to him that it is just protocol. We can and will not get into debate on site, I'm afraid.
The point, Mr. Dowson, is if somebody wants to say, I think you really need to stand here and look there, that's permissible. So you can tell people they can do that. It's just not more than that. So far as numbers, we'll cooperate in whatever arrangements are necessary.
Mr. Connell circulated an itinerary yesterday. If that's adopted, could I have a copy? Because although I want to participate, I'm not fit enough to walk such distances, but I could be at key locations. Like if
I'll make sure that Mr. Coleman has a copy.
Does anyone have any other points that they wish to discuss this afternoon before we finish up?
Nothing here, ma'am.
Okay, well, if everyone's content, then we'll reconvene at 9:30 on Tuesday morning back in here, and we'll commence with the two witnesses for the council, and that will be
Mr. Mr. Callender and Dr. Chatterton.
Chatterton and Mr. Callender in reverse order. Okay, thanks everyone.